Is it Come On series?
Yeah, we're live.
Live. Hello, everybody in the chat room. Good evening again. Today is the 21st of July, 2017. And on the panel today, we have Chris up there, which I can't read, which you'll show us in a little bit. Today is the 21st of July. Oh, my goodness. I've done it. And on the panel today, we have Chris up there, which I can't read, which will show us in a little bit. Right, it's off now. Phew, sorry about that, guys. From Holland, my Greek partner, Patricia from the UK, Robert from America, and we've got Judith from Israel. Robert's our guest today. So how are you, Robert?
Oh, I'm doing great, thanks. I'm at the Experimental Aircraft Association fly-in in Oshkosh, Wisconsin. It'll be the busiest airport in the world for the next week. And what's interesting about this is that people will fly in from all over the world. And I am particularly interested because of the people that attend, as well as the aircraft that will be displayed as well. And I understand they're going to have some astronauts here too. There are more actors than I realized. But
they're everywhere.
They are. Well, you know what's funny? On my way here, I saw a puddle, and it was just a reminder that the water is flat and level wherever I find undisturbed water, whether it's in the water jug that I put on my photography, or the glass of water or whatnot that I have at home, or the toilet, the bathtub. The water undisturbed is all flat. And we've got one of the biggest freshwater lakes in the country, just a few miles from here, Lake Winnebago. And what's interesting about Lake Winnebago is it's 31 miles long. And on the 4th of July, I was able to take photographs of fireworks from one end of the lake to the other. And the fireworks that I was able to capture were just private fireworks. They were not like going thousands of feet in the air. It was just on the horizon, just little fireworks going off. And essentially what that means is that there's over 650 feet of missing curvature there. And the water is so obviously flat. So what we have is, they call it an escarpment that's on the east side of Lake Winnebago. And it's supposedly some of the geography from the Niagara Falls. I don't completely understand how that all works out. What I do know is there's a bit of elevation around the lake actually on the east side, and the water is so obviously flat in contrast to the elevation that's around. Now, to add to this, what's so fascinating to me is we have one of the very few north-flowing rivers. The Foertsch River flows out of the north end of Lake Winnebago, out of Neenah, goes 40 miles into Lake Michigan. And with the 40 miles, that's over 1,000 feet of missing curvature. And water just doesn't flow uphill. It flows downhill. If the source of the water is high enough, it will apparently go over a little bit of rolling landscape, but it won't go higher than the point of origin, from what I understand. And in this area, I've got it in my photo album on my profile, where they talk about the waterway that early on in the history of our country was utilized, where they combined the connection between the Fox River, the Wisconsin River, and the Mississippi River. what's interesting about the Mississippi River and the connection that it all makes is that sharks have actually come up from Louisiana, from the open ocean into the Mississippi River, and it's a historic event. There were a lot of people that were bitten, and some died from shark attacks way hundreds of miles up the Mississippi River. Well, the point of all that is that the level of the water that's all connected is, I believe, quite a bit different than we're told. In fact, when I'm on my compass with my iPhone, it'll give me a reading of over 700 feet. And then if I ask Siri what my elevation is, I'll just simply say, what's my elevation? And I'll get a variety of answers that are very inconsistent. Even if I'm in the same location at another time, it'll give me different elevations, sometimes 100 feet different, even from the same location. One of the most interesting responses that I got was right at the right where the Fox River flows north out of Neenah. I said, and it's a very wealthy neighborhood, and I said, what's my elevation? And Siri says, well, that's an interesting question, Robert. And she never got back to me. And I've had readings where I was up in the lighthouse and I got a reading that was like 5 feet or 4 feet lower than when I was on the ground. So none of it really makes sense except to say that they're not disclosing what our actual or my actual elevation is. I think that's significant because they don't want us asking that question. They don't want us to know. So
that's why I
like you,
attempt to get all the data together. So far, I figured out I can actually pinpoint the location and scan from that location in a certain grid value that you can actually see more detail from it, and map out a complete river, for example, and see how the heights actually differ on the flat Earth, because it's a complete flat map in a square.
right. And well, yeah, and what I noticed too is that I know I've mentioned this before, but 3 weeks ago when I came northwest from South Carolina, 1,200 miles, I know there's a time difference, a time zone. That's not what I'm talking about. The sun was above the horizon for an hour longer than in South Carolina. That just shocked me because it doesn't go along with the heliocentric narrative. It doesn't match the spinning globe lie. It's one of the things. And then, as I'm sure you know, I take a lot of sunrise and sunset pictures and follow the sun and the moon through the day when I'm able. And I can tell you that the path that the sun and the moon travel from the perspective that I am up here in Wisconsin is very different than when I was in South Carolina. And the amount of visibility of daylight, in addition to the actual sun being visible, is substantially more. And just from the standpoint of geography, to think about it, I keep my my clock on my car to the Eastern Standard Time to just try and keep it straight in my mind, because my computer and phone, all of that changes to match my current geographic location. Well, what I noticed when I first got here is the sun would appear in South Carolina about 5 minutes sooner than it appears in Wisconsin, 1,200 miles northwest. And then the other day, it was 9 minutes difference. The numbers don't lie. If the projected arrival and departure from our perspective is accurate, and it has been from everything that I've been able to see, a difference like that indicates it's running a different path. it's a different perspective. What I find so amazing is with such precision that projected arrival and departure actually is. They know what they're doing, whoever they are that set this up. Well, that was kind of my introduction. I'll just kind of toss that out there and say it's pretty fascinating to see this old neighborhood from a new perspective.
You've quite enjoyed that, haven't you? Because although you love Myrtle Beach and you're there all the time, I think you're like, this is a toy to you, isn't it? It's like a new toy to go and record all this other stuff.
Well, yeah, it's interesting to see and really heartwarming to spend quality time with our sons and my dad. It's so interesting too that now that our sons are older and they have cars, they're more interested in having me help them with some of the mechanics. And another very fascinating part of this is that they can YouTube a video on how to do like changing the headlight in their car or how to install different lights. And I've worked with them on that as well. But they have a different vantage point too, now that they have an interest in doing some of those things. And it's also kind of a commentary on our society where we've got busy parents that kind of relegate some of their parenting responsibility to digital media. I know that we did that a lot too. And then there's almost like a surrogate digital relationship where the children are learning from YouTube videos and the internet what used to be imparted through interpersonal connections with like their dad or their mom, the different family members. So it's different. And I'm just glad to be able to enjoy the time with our family. But it is fascinating to see things so differently. I know when my dad told me over 20 years ago that the Fox River flowed north, I thought, well, that's interesting. How does that work? Oh, well, what's for dinner? I never really gave it much of a thought. And when I send out the post about the Fox River and the missing 1,000 feet of curvature, and I get the response that I don't think you understand the how big the world is kind of comment, like I'm unaware. Well, I'm aware of the official narrative that it's supposed to be. If the spherical curvature for 8 inches per mile squared is not accurate, then what size is it now? And instead of a sphere, it's a pear. What is it actually? Just show me a picture of it. I got a camera. You've got rockets. You've got fancy cameras. Just let's see a picture of it. You don't have to Photoshop it. Just let's see it. And they're not going to do it. They don't want us to see it because of what may be in the background. I don't think, it's very possible that it's way bigger than they're telling us.
Oh, a studio's in the background.
You never see the fourth.
Yeah, they're not gonna show us. That's okay. I don't.
Yeah, the fourth wall syndrome. Yeah, exactly. Yeah.
Well, that's one of the reasons why I take great pleasure in doing 360s. I want people to see it's all real as best I can tell. I'm not in a studio, but then too, like I kind of look at the whole Earth as the set that I'm working. When we talk about lens placement, I'll move the lens just a little bit.
Actually, I made a mistake.
To see
it's not a studio, it's the green screen. You need a green screen. That's what they use.
Oh yeah, they use a green screen. I'm just using the real deal. But what's funny about that is a lens placement moving the lens ever so slightly changes everything. Well, when I take the lens 1,200 miles away from where I normally am, the difference in proportion of the size, the apparent size of the sun and the moon is quite a bit different. I notice with the magnification, I'll zoom in the full digital zoom with the P900, which is 83 times, and it's obvious the proportional difference from here to South Carolina. It's a significant more. I'm trying to figure out how to express it as accurately as I can. Just simply to say the 1,200 mile difference makes a big difference. And if it were truly 93 million miles away or 238,000 miles away, the sun and the moon respectively, 1,200 miles wouldn't even be noticeable. You wouldn't notice that.
Well, supposedly, the sun is supposed to see us as a speck of dust. So if it was a speck of dust, oh golly.
Yeah, they're making this stuff up.
So where are you now then, Robert?
Well, right now I'm at the EAA. Let me go ahead and see about flipping this around. And it's raining here right now, but there's a couple of propellers. We can see them on each side of the roadway there. Yeah. And there will be planes flying in from all over. Now, one of my friends, Jay Hurd, is going to give me a wristband for this event, which is really nice. And that's a really valuable access. I'll be able to go some really interesting places with that wristband. And so this is actually the Air Venture in Oshkosh, Wisconsin. They call it the 2017 EAA Air Venture. So go ahead.
I wonder, was there a forest? Because the road itself is actually called Forest Home. When you're looking at
Forest Home. That's that's that was just one of the little roadways around the edge of the field here. And I don't want to go driving around out there now because they're all setting up everything. But what'll be really interesting, I've been here before where they actually had Sir Richard Branson's that plane that went extremely high altitudes. I haven't researched it since I saw it. I just remember it was a plane that supposedly went about as far up in space as they could go. However high that is, I don't know.
Yeah.
But what I was hoping to find out here too is what are methods to actually determine elevation? What are tools for that, and how do they actually know what elevation a particular piece of land is? For example, when I'm at the ocean in South Carolina, that's sea level. We know that. That's the body of water that covers the face of the earth. And yet when driving hundreds or 1,000 a mile away, how can they possibly know what the elevation is? What are the tools that do that? And now that the that whole satellites are pretty much they're make-believe. When they show satellites traveling through space, which other satellite is taking the picture? People need to be putting their thinking caps on and just think about that. Why aren't they getting knocked out of space by debris and all of that? They're making it up. So
why can't the ISS space station see one?
Oh yeah, well I actually posted a link where Google Earth is now making it possible for us to go to the ISS, and I called it the International Fake Station, I think, where they bring us this science fiction. I like using science fiction because that's part of the theme. It was with Flash Gordon and Lost in Space, and in the early 1900s they had movies about space as well, and we've got the H.G. Wells and all the different 2001: A Space Odyssey, and then Star Wars, and then when we fast forward to more recently, and we get movies with like Inception or Gravity, and they're very elaborate in their ability to really mess with our minds.
Yeah.
I think they did try and make us believe that we would be going and living on the moon at some time, didn't they? With Space 1999, and
oh yeah,
there's this real push that it looked like, you know, I suppose in our minds it was put, yeah, we're going to go live on. We could live on the moon.
Well, I remember in the 60s we would get this space food. They were like a really nasty tasting plastic wrap, or a foil wrapped. It was kind of funny. They wrapped this terrible tasting candy in foil, and they also wrapped this hodgepodge of curtain rods and aluminum foil that supposedly landed at the lunar lander, and then they've got the lunar rover. And how did they get all this stuff there? How did that happen? And you know, kind of where we're at, is many of us that are aware of the deception, it is just so obvious that it's not possible. It's actually laughable.
No, it's just ridiculously not possible.
Well, you know, when people say, you don't believe we landed on the moon, I'm like, are you freaking kidding me? You bought that? I bought it too, but then all of a sudden the veil was pulled off of my eyes, and now I realize it was like one of the biggest hoaxes ever perpetrated on humanity.
Yeah, for the fantasy books, the most beautiful ones. I mean, I've read the whole collection of Storm as the strip, and Trigia, and Ender's Games, the complete books. The third book that they won't film. That's actually the most wonderful book of the whole series. All the Beyonds, etc. You know, all kinds of things, and it's probably unfilmable as well, because
oh yeah,
you need to
what
read
do
the
you
book
call
to actually realize it in your own head, because there you can actually see the things. And yeah,
call the satellites? You call them, what is it? Satelloons.
Satelloons. Every unit is actually up there, but then under a balloon, all individually, not connected as one big station, but as actually individual units doing particular stuff there. I don't know what.
Do you think they could have lasers on them, series?
Yeah, there's just way too much proof what actually says they were sent up with balloons, because that's the actual record. And then the rocket stuff we have to believe, because they go up there and then we don't see it. And then particularly this switch over to the virtual part of the rest of the trip. Yeah, right. Just before the moment they actually crash down.
Well, you know, one of the things that I use as an example when people say, you know, I've got a satellite dish on my house, there must be a satellite. Well, one of the thoughts I have is to say,
there is a satellite.
Well, look at a football field.
With its hard stuff, they actually create a reflector in the sky, where they can communicate like the dishes, just to a tower on the side of the reflection. So exactly. Why is your always at a certain corner forever?
Well, like, for example, on a football field or a soccer field, they'll have a dish that collects the sound from the field. There aren't any satellites on the soccer or football field, yet they're using a dish. Like it looks like a satellite dish, but it's clear, and but it's very effective at doing what it does. Just because there's a dish doesn't mean there's a satellite. Like you said, they're bouncing it off of the either the firmament or the atmosphere.
Robert, I bet
Yeah.
you Chris knows, don't you, Chris?
Is Chris?
Chris?
Yeah, you're muted.
Chris, you need to unmute yourself. Can anybody else unmute Chris?
Yeah, I can mute him, but unmute is another one.
Hi, Chris. We're trying to.
There we
Yeah,
go. Yeah, sorry, I got too many windows open. You guys are chatting, and I'm opening up other windows here. Yeah.
Where the hell is the hangout?
I was actually gonna do a bit of a. If I can get the right one going here.
Sorry, Chris?
I was trying to open up the NASA website there for the Balloon Launch Center. It's called Columbia Balloon Launch Center. It's in Antarctica, so it's all balloon based because there's some really cool pictures there. Some of those balloons can lift 32 ton minimum, 4,000 pound. Oh yeah, I was going to try and bring up some pictures here while I was chatting, but I get too many windows going, and I ended up muting myself. I couldn't get it done, but just a second here.
Oh, thanks,
I go
Chris.
on the NASA station here. Screen share. Application. There. So that's just an example, the scale of those.
Cool. Can they use those for anything else as well?
That are, they're round and they're microwave based stations, and the size of the stuff that they're carrying around. And I find the mockery is a little interesting too, right? There's one called Palestine 2017. And if you go to Google Earth, Palestine has been taken right off the map. It doesn't even exist on Google Earth anymore. You search for it and you get nothing but water off the coast of Africa.
So what does that mean then?
Well, they're just mocking people, right? It's just to put it in your face, right? Here we are out in the open. Here's your satellites, and
Yeah.
Well, I was quite surprised, Chris, when you actually found out where the stars were, where the star-making places were.
One side,
You could
they're
find
fooling you on one side, but they're bragging about it on the other side. And we can't connect the both, it seems,
well, that's it. Yeah, they just keep putting it in people's faces. Yeah.
And I said, oh, I've forgotten what I was going to say now. I've forgotten. Oh, yeah, the star-making places, they've actually got like tutorials. You can actually find videos and they'll say what they're doing. And they'll tell you that they're making the stars and they can't get any higher than 60 miles up. And you think, find it. Like, I would have thought that you wouldn't be able to, as everything's so lied to us, I was quite surprised that you could find them. I think Tyson in our group, I think it was Tyson or Owen, one of them put up the post about the stars months ago.
Palestine.
And they showed you how they made the stars in the sky with the beams, and that they could go much further. The machines could, but they can't go higher. But then we've had that John Hutchinson, who's now subbed to our channel, and he also said the same thing.
Yeah, about 100 kilometers, I think, is the limit. 60 to 80 miles is about the max that anything's really ever gone in the history of rocketry, as far as I can tell, and all the research I've done. Yeah.
People have got to take the zeros off, not millions, just miles.
Yeah, yeah, exactly. Yeah, Yeah, you know, you can see where they name a balloon, the Palestine project, and then they, Google Earth sticks Palestine out in the middle of the ocean. They've taken it off the map because it's a disputed area in the Middle East, and so they pinned it now. It's been pinned there since last year, right? It's just in the middle of the Atlantic. So I mean, it's just continual mockery, and it's just not right as far as I'm concerned.
That's a 0 point.
Yeah.
Where I actually started to ask myself, hey, how can I get this particular info? Where's the elevation data?
Yeah.
That's an island there.
Yeah, 0 point in the middle of nowhere. Yeah, it's Palestine. Yeah.
Okay.
Yeah.
It's called Palestine.
Well, yeah, Palestine used to be part of Israel, right? It's part of the Giza's the Gaza Strip there, and so they've taken it off Google Earth and put a pin out in the middle of the ocean, but you can't find it where it used to be. So
maybe
it's all part of that. It's all part of that.
0 point is a nice point to actually start the actual details coming from the other side.
I was going to show you. Yeah, if you do the math on it, it's like Robert's saying it. Anybody with a mind that thinks about it just for a few seconds could figure out that, well, you can't have a thermosphere that starts at 100 kilometers and the temperature starts rising, and then the temperature goes up, starts rising rapidly until it reaches 4,000 degrees or more, and then put a rocket into that environment that has a 3/4 inch wall of aluminum skin on it, that with a flash, it's full of liquid oxygen and aluminum oxides that have a flash point of 80 degrees, and they expect it not to blow up, right?
Yeah, what was that particular firework with that particular aluminium powder?
Well, that's it, right? It's the same fuel. It's aluminum oxide and different oxidizers. Is the basic fuel that they use in those rockets. So there's no way they're going any higher than 100 kilometers because it's just too hot.
Yeah,
right? It cools down first and then it gets hot, right? So yeah, so the flash points just don't work. It's impossible. And then of course you get up a little higher than that, and you're into the 650 degree range. And aluminum melts, plastic melts, quicker than that. Everything boils. Yeah.
Yeah.
Of course, your blood would boil in a vacuum anyway. So good luck with that. Huh? Yeah. It just becomes more and more of a joke. The more you think about it. But,
so it is really hot up there. I suppose it would be. No, because the closer you are to the sun, the colder it is. The further you are away, the warmer it is.
And there's there's a plasma layer, right? So it goes in layers, right? It goes, yeah. First it goes cold, then it goes hot, then it goes cold and hot. It just keeps switching polarity as the polarity changes. The plasma field is extremely hot. If you look at the Libyan glass,
that's like being microwaved, sort of hot, that kind of hot. Like
oh yeah,
what we were talking about the other day. Like it's an energy that's happening. You wouldn't see it, but it would, yeah.
Yeah, the plasma layer. Like I'll give you an example here. I was trying to look some stuff up. Where was it? So you want to know what the sun's made out of? You just look at the plasma colors, right? It's and this is again this could be mockery, right? What kills Superman? But krypton. Well, krypton glows, a nice sunny color. So krypton and helium. Whereas if you look at helium, right? So helium is one of the primary constituents of the noble gases that glows in plasma like a sun, and it's the most common at those altitudes. And then krypton would be the next one. So you break them out by their molecular weight.
That's like the Northern Lights colors, isn't it?
Well, that's yeah. Helium's the lightest, right? So its molecular weight is 4.003. So it's the lightest of the noble gases, or one of the lightest. I think it is the lightest of the noble gases. So I mean, obviously that would be the primary gas of the sun. So as the the plasma energy comes in from outside, it focuses at that point in the magnetic field, and it glows like the sun. So wherever you look at it, you see the glow, right? Because our lens, our dome lens, is a focal point. So as we look up through it, yeah, we see it as the sun.
In the Northern Lights, though, there's usually a couple of colours. So what's that then?
Same thing. It's just plasma in a magnetic field. So the magnetic field excites the gases. So again, it'd be the same type of gases,
Yeah.
based on their weight. So argon would be the pink, which would be the heavier. So you'll see the pink below, then the green would be above. You just separate them by their weights, and so that's where the colors come from. Just a big neon bulb. We're pretty much inside a giant neon bulb system. If you see blue, obviously it'd be quite heavy. It'd be quite low to the ground. But I don't think there's much xenon.
Where we live gets stranger and stranger. We're in a neon bulb now. Right.
Pretty much, if you think of it that way, it's an electroplasma magnetic field. Is a toroidal type system, and we're at the center of mass. And that gets back to what Robert was saying, about how do you calculate elevation. And I might have reviewed this once before, but it's when we do it in construction, you set up the
1 second,
theodolite.
Robert, are you there?
Let me. Can you hear me now?
You are. I wondered whether you were talking to someone again.
Well, I just muted myself. I understand as far as elevation, it's a bit of a challenge when we get inland. I know that they have particular elevations that they attach to an area, and then quite often when we listen to aircraft, like a large jet, we're leveling off at 37,000 feet, which would apparently fly over any mountain in the world, because the tallest mountain, Mount Everest, is supposedly 5.5 miles tall approximately. So as far as knowing what the actual elevations are, I think the water and how it connects to like the ocean in the United States would be one of the clues. And I'm still searching for that. Now, with regards to elevation, did you have a particular question you wanted to ask me about?
I think he was going to explain something to you, Robert.
Okay, go ahead.
Yeah, if you're wanting to get into the nitty gritty of it, when we do the surveying on projects in construction, we set up the theodolites, and they tie into ground stations, and you let them sit for 24 hours until they calibrate themselves. But what they're calibrating to is a mass constant in time that's set to the year 2005. So it's the mass constant, which is the center of velocity of the plane that we're on, right? So it's always moving in time, and so the tectonic plates kind of shift and everything. So we set it to that center of mass. It's a fictional center of gravity. It was established in 1900, and the last time it was updated was in 2005. So if you go and look up WGS 84, so just look for that, which is the National Geospatial Intelligence Agency. So look up WGS 84, and it explains exactly how that's all figured out. And you'll see that it's just a gravitational, fictional center of mass.
Yeah, they're making this stuff up. That's at least is best I can tell. That's what I'm coming up with. Is like, for example, when I was talking to the drone pilot at the Life Fest, I asked him how high the drone was. He said like 345 feet. And I said, is that above sea level? He said, no, that's above the top of the picnic table that I'm sitting on. I said, okay. And I said, how can you calibrate it to sea level? And he said, well, there's a program for that. And I'm like, oh yeah, okay. So you connect to the internet, and then they give you an assessed or they attach a value to your geographic location, whatever they want it to be. So that's why early on, when we were using the digital devices, the iPhones and the Androids, and we're wanting to pull data of the elevation of the sun and the moon and our geographic location, all of that stuff is using the tool, the enemy's tools, and it's all suspect to me. That's why when I look at the flat water, I get that. Whether it's the glass of water or the toilet water, the water's flat.
Well, that's exactly it, Robert. Like, yeah. When you look up that WGS84 and you read the first description, you'll see right away the giveaway, because the first sentence is that WGS84 is an Earth-centered, Earth-fixed terrestrial reference system and a geodetic datum in time. Period. Right? So it tells you, and that's what we calibrate all survey data equipment to a GPS system that's ground-based, and it's all relative to itself. And that's exactly how they're doing it. So like you said, the drone pilot sitting on the park bench, he just calibrates the drone to himself, and then it's relative to all the ground stations everywhere else, right? It's exactly it.
Yeah. So the evidence of a shark being able to swim up the Mississippi River from the ocean and eat people or kill them is evidence that the ocean is connected, obviously, to the Mississippi, which is also connected to the Great Lakes through the waterway that connects the Wisconsin River to the Fox River. And I know that there's a series of locks, but what I understand they're doing is the dams and the locks have an effect on the elevation of the boats, but they're in no way even close to the supposed difference in elevation between the hunk of ground that I'm on and the ocean. The drops,
for sure. Yeah.
They don't add up.
Yeah, if we could curve water, we would have just built a bridge over the Panama Canal, right? We wouldn't have to do locks. It just would have been a nice curved bridge, and they just boats right up over the bridge, right? Yeah. I've never seen that in an engineering project. Yeah.
Oh, I see. I could hear a slight noise. Robert's driving.
Oh, let me mute myself again.
So this is a little bit different topic I wanted to kind of bring up. Well, I got you all on here. It's a friend of mine, Bradley Gillen. He's on my Facebook friends, or he does a lot of this research in private with me too. And let me see if I can bring it up. Not the plasma, what I'm looking for.
And Series has got a picture up. I'm sure Series will want to talk about his picture up in a minute. Wait, Series.
So you can go, this is a website. This is the Library of Congress website. Right. So it's the U.S. Congress, Library of Congress. And this is so people can see it. You just Google that. So it's the chroniclingamerica.loc.gov. And you go on there and do a keyword search for the Earth is flat, that type of idea, and you'll see that you'll come up with all these articles from the late 1800s. So the debate was actually in the papers in the 1800s, and I'll stop sharing this one because there's one that I found was really interesting. And I'll bring up a different one here. I wanted to show people it's quite fascinating. Is it this one? Nope. Maybe it is, maybe it isn't. I'll get the hang of this here in a second. You wait.
You're doing good, Chris.
I'm going to open up this bunch here. And then share that. Da, da, da. I'm trying to manage 3 windows at a time here. That's the problem. So I want this here. There we go. So here's one that was in the papers, and this one was from 1900. So a man says that the earth is round and he may be thrown into prison. And this was a professor in English in England. Made the front page, right? So it's painful to read that Sir John Gorst, the head of the British Educational Department, is in serious trouble and has been threatened by Mr. Ebenezer Breach and other taxpayers of England, the city of Portsmouth, in the Kingdom of England, for prosecution under the Impostors Act, because he claimed he was trying to teach that the earth was round in a school. And they were going to throw him in a break, right? But they're going to put him away. It's a long story. You can read it. It's just fascinating how, the debate, here we are in 2017, and it's basically taken to the web. But this story, this is 1900, right? So they were still, this is making the headlines in the 1900s. So, when people that defend the globe say, oh, well, the flat earthers are trying to challenge, 400 years worth of science. Well, no, this is front page news in 1900s, less than, it's like 120 years ago. And this goes on till the 1930s. They were still fighting about it in the papers and threatening to put people in prison if you claimed the earth was round, right? But somewhere along the lines, probably in the 40s, World War II-ish, it took hold somehow. And we've been on the ball ever since.
And the same lie as that everything before that was the ball.
Right. Yeah, but it's not that old of a problem. It's this is July 12th, 1908, right? Yeah. So it's front page news. Right? It says the earth is round, you might be thrown in prison. Yeah. So thanks to my friend Bradley for bringing that to my attention. He does a lot of great research.
Yeah. This is a good one.
Yeah. Yeah, it's great. Yeah, so go to that website and you can find all kinds of stuff. They're fighting over gravity, Newton.
Very old newspapers.
Yeah, the old newspapers. You'll find the truth in the newspapers.
Yeah, right to your face.
Yep.
Yeah.
It seems that they've seen, like, maybe they were discussing it then, but they've bred us into a generation that it isn't. We are now.
Yeah.
Looking at all this stuff and debating it then. What happened between then and space?
Yeah, I don't know exactly. I'm trying to figure out, like, just for my own curiosity, I'm trying to figure out when the ball thing took such a hold in the school system, right? Was it when, post just around the end of World War II, when the school system changed? I mean, the school system did change around that time, right? It was taken over more of a institutionalized system. So I'm thinking it kind of came into popularity around that time. Certainly not 400 years ago. And, Robert was talking about the guy, the drone pilot, and trajectories and things. I was watching the video, I can't remember the lady's name, but I think her name is Talkaholic on YouTube. But she said in her video, she said she was military and she was now currently in college studying trajectory and stuff. And she challenged her teacher, and that's what her blog was about. It was a live talk blog. And she said that in the class, the teacher said, well, if you just use XY coordinates and take the time of the sound, the flashbang sound, you can calculate real quick where the shot came from and fire back on the battlefield. So she was training for military ordnance targeting. And she challenged her teacher and said, well, you know, how do you do that with the curve and the speed of the rotation, and you're just using a flat plane? How does that work, right? And of course, she was ridiculed in class by her fellow classmates and everything. So I took the time and I commented on her video and told her to keep up the good work, you know, because it's true. You know, on the ball, if you're on a spinning ball, the calculations would look more like this, right? You know, find the radius of curving a trajectory on a curved space, right? You know, it's such a complex solution. I mean, look at that. It's vector mechanics, right? Because the ball is curving. You're trying to go X, Y on a curved axis. You get a tangent to the line. Say if you're 45 degrees north, right? You got to take cosine of the angle over the curvature, and the time and the speed and the weight of the bullet and the resistance of the air, you know, and all that into plus magnetic field. You know, put all that in there and try and figure that out while your life is in danger, right? I mean, these guys aren't doing that. They just go X, Y. They count, you know, the number of seconds from the point when they heard the sound times 750 miles, you know, per second. They do the math, you know, quick, X, Y times 750, you know, whatever. Divided by 750, and it's, you know, they're 4 clicks away. That's, you know, they got to be able to do that stuff fast. So it's just common sense. So, yeah, it's flat. Yeah.
Throughout the map.
Yeah, yeah. So I like doing the research and actually, you know, considering the math, because I learn a lot when I start looking at this stuff. So okay, I see how you would have to do it in reality, and then I go through the equations and check them all out. Absolutely, it's I enjoy that kind of stuff. And then Einstein, in Einstein's theory of electrodynamics of moving bodies, this is where the gravity thing comes from. So they took the center of gravity as a fictional point, and that's where the geodetics, which is what they use to calibrate all the equipment to.
Because he of his mass.
Yeah, because on the very first page in 1905, he's talking about the path of, you know, the electric, you know, conduction in moving bodies, right? The conductor in motion. And he actually says examples of this sort, you know, together with the unsuccessful attempts to discover any motion of the Earth relatively to the light medium. So what he's talking about there is Michelson-Morley's experiment, where they had the laser set up and they couldn't find any change in the light path relative to the motion of the Earth, right? So it's not moving. It's not moving so much that it even alters the path of light in a laser across a distance. So then he goes on to say that, you know, the phenomena of electrodynamics as well as the mechanics possess no properties corresponding to the idea of absolute rest. So this is why when you set up the theodolite, it's set to a fictional center of gravity in time, a point in time. And that's what we're calibrated to. It's just a point in time, because nothing is ever at rest. It's all a torque center in time. The magnetic field has a center, which is always in motion. It never stops moving, but it's you know, a very subtle motion. It's just torque in time. So it's fascinating when you think about it. Right? It's a self-referencing system.
Yeah.
But you can look this stuff up. You know, look that up on the electrodynamics of moving bodies, and read through it. You'll learn a whole lot. You know, when you go to college or whatever, they say, "Oh, E equals MC squares," and that's it. That's all you need to know.
Yeah.
Right? They don't actually go into detail into this in detail. Right? Because he says time here denotes a time of stationary system. Right? The positions of the hands of a moving clock. It's just in this whole theory is referencing a stationary coordinate system. So it's right coordinates in time. And it's a uniform motion translation of relativity. So it's referencing itself always. And then you can keep scrolling through it, look at the math. And if you get to page 11, there's an interesting note on page 11. So he goes through all the mathematics, and then it says note 7, which is referring to an equation up here. So it's not a pendulum clock, which is physically a system to which the Earth belongs. In this case, and he says this case had to be excluded. So it was taken out of the calculations. So the gentle swaying motion of the Earth, just kind of sways over thousands of years. It's such a small oscillation that the physical, you can't physically feel it, right? It's just like you're being rocked in a cradle over 25,000 years, which that's what causes the precession of the stars. They do go backwards over 25,000 years.
Yeah.
And then that's one, I think it's called a Baktun in the Mayan calendar. So it's, it's a flat plane, it just rocks, and it just gradually goes, in one revolutionary circle over 25,000 years, which I find is interesting because that's 1 degree in 72 years, and 72 years is the average lifespan of a human. So in every lifespan or every generation of one human lifespan, it moves 1 degree. And I find that fascinating because, it's got to be tied into, the number of heartbeats that you're allowed to have in a lifetime, right? Tied to the motion of the backwards rotation in time, right? It just blows my mind when I think about that kind of stuff.
The number of beats.
That's the flower of life, right? That's the whole flower of life going backwards. So it rotates backwards in time, right? 1 degree every 72 years. And when your 1 degree of rotation is up, that's it. You're done. Your clock is done ticking, right? On average, right? Yeah. For people that kind of research, it's a lot of fun. Yeah.
It's half of 144, actually.
Yeah. 12 squared. Yeah. Precisely, right? It's 12 squared. Right? 12 hours a day, 12 squared, half 144 is 72 years, which is 1 degree of backwards rotation over 25,750 years. Right? The site, and you can double it again, you get 144,000. Right, which is the 12 tribes of Israel in the biblical terms. So 12 times 12. So I think it was 12 tribes of 12,000 men, 144,000, which is exactly the length of the solar count in the Mayan calendar. And the arc seconds, you can actually figure out the arc seconds of the sun's motion over 2,500 years or something.
If
Fascinating.
you could just make it just a simple table of all the cycle and information about the objects, and just animate that, photograph that, and see what reality itself actually brings, and then see how the whole mechanics behind it works, the physics behind it.
And it all comes back to the center, right? All back to the central harmonic, or the center point in time, which actually ends up as a C note. It's a C note. In musical terms.
So, series, what? Explain to people what you're showing.
Yeah, what am I showing? I try to actually line up the temperature map of the air with the chakra system. I think I didn't completely line it up yet, but in a way, I figured it seems like the Mandelbrot pattern in a way, that you see the bubble below and the bigger bubble above, in how the temperature goes to lower and to extremely high eventually. And I think there's even more beyond the thermosphere, but I have no idea. Yeah, I think having kinds of this kinds of data information in computable way that I actually can make it a 3D visible layering of the temperatures, then you can actually see it from the side or something. Of how
That makes sense, yeah, because
narrow
the center of the heart would be approximately at 96.4 degrees would be the throat chakra, right? That's about your normal body temperature is lined up there. If you line it up that way, that makes sense. Which is the biggest, that's the biggest mean, the biggest one there. It's
and probably higher up. It's with all the in the ether layer. I think are the moon and sun, etc. as fields around this in other octaves, as this is one part of a body in one octave of the chakra system, and then on top of that you have a second chakra system of the first body beyond there, and etc. Or maybe several in there. I don't know. It builds up into a bigger body of 7 layers as well.
yeah. You know, it's amazing how, you know, the pattern, once you catch on to it, it ties into everything. Like you'll notice when you look at the germination of a chicken egg, for example, it takes 7 days for it to develop in the chicken, and the egg itself has 7 layers in 7 days, and then, you know, I think the chicken will hatch in 70 days, that type of thing, or whatever, however long they have to sit on it. I can't remember now, but it's definitely related to sevens, right? So 7 chakras, 7 layers of a chicken egg. And the chicken egg is made of calcium, which is a dielectric. So the 7 is like the center point, or one of the prime numbers, right? It'd be a prime center, I think, if you did it that way. So maybe think of it in terms of
that. Shows us all this work, right? Because he's got very colourful diagrams of elevation and those things. What is it you see now because of your work when you see these things? Because obviously we're still explaining Ceres' work as you're explaining yours. So what in with yours? Just
well, I see when I look at the same. I can try and bring up some pictures here. It just overlays one overlays right on top of the other. I'll bring up some different pictures here that might help explain as I talk here.
It's just good for the people, you know, watching in the chat room to understand how that Ceres' work it ties in with your work, like your work ties in with his.
Yeah, so Ceres sends me, you know, the 2-dimensional with the overlays and the Mandelbrots, and it all ties into the center. And then I'd take it and apply magnetic fields relative to what he's come up with in his diagrams. And you'll end up seeing that it lasered over top of the magnetic field. So the center of the flower of life and the whole concept the Ceres is working on, it just ties it into the magnetic fields. And from that, I can take the magnetic field and then scale it to the same dimensions of the map itself, which is kind of what I did in this screenshot here. So you can see where I had the moon group map, 12,700 kilometers wide, laid over with the magnetic field map, and then that generates the north and south poles on the donuts, which is lined up with the magnetic field. There's 4 points on the square map where the magnetic field of the Earth plane lines up with these 2 toroids. And from that, I can scale the next one, which is the neutral, which is this one.
Hey, I wonder if
Oh, it just skipped another toroid.
I wonder if these toroids also oscillate in one in a way or another.
Well, they there's like a gyro. So the field. You look at Ken Wheeler's work. The magnetic field appears to be like when you hold over a ferrocell, it looks like it's stationary, but it's not stationary. It's always in flux. It's always in motion. It never stops, which is why our survey equipment is calibrated to that center point of magnetic flux in time. So these are like stationary donuts. But fields are always in movement, right? And when they move, it's taking them with it. And it just keeps rotating east-west, east-west. That's why all of your subscribers to your channel and on the moon group, I took the moon map. So if you can see the moon map, they're on the ground looking at the moon, and everybody's looking south. And that's because the moon toroid, from a side angle, I had to angle it to make it work within. So you can see it's kind of angled because the poles line up in the center of the map here. You got to line up the poles. So the moon travels this sort of an ecliptical. That's where the analemma, if you actually took this and rotated it and keep the moon in that donut field, you'll end up seeing a figure-8 analemma shape, right? Because as the moon flips from side to side, so it would rise in the east over here in the morning or whatever, set in the west. You have to imagine that this donut is rotating in a magnetic field, figure-8 analemma. So that's how they tie together. Yeah. So I've directly taken my work in a 3D model off of series of maps to scale. So it's a real life. Yeah.
Mm.
So then what I end up doing, so the fascinating part here is once I do that.
Oh, we can only see your icon right now.
Yeah, here we go. So now can you see it?
No, just your icon.
Oh, hang on again.
That's it. It's there now.
Okay. So then the next step of the model is to take all of that information and I put it into the model, and then I end up being able to scale everything from the fields, and then I can end up reproducing moonshots, sunshots, sunrise, sunset, anywhere on the map. And it's based on I just have to put in the magnetic fields, but you'll see where they actually lay in there on that map. Fascinating part is if I take this cube.
Joined us. Sorry, Chris, just saying Dave Marsh has joined us.
Oh, hey,
hello, Dave.
Hello, everyone. Can you hear me okay?
Yeah.
Yeah, we can hear you. Chris is just explaining a bit of how I asked the question about how did their work cross each other, and he's just explaining it. Sorry, carry on, Chris.
Yeah, carry on, Chris.
Yeah, so you can see where the magnetic toroids, basically enter the Earth's surface, and that's what generates the motion of the moon and everything else. This is actually a crystalline type of space environment that focuses the sun here to our perspective. And if I turn that off, it's actually a cube with the corners knocked off it to make a diamond. And if I turn it off, you'll see how everything goes white, right? So we need that single anisotropic light source, which is the sun. Yeah. As soon as I turn the cube back on to focus the light here to our perspective, then the sun appears in the sky. But if I turn it off, it just diffuses white. So, yeah. So that's the fascinating part. That was a discovered. Is like, oh, well, light has to be an anisotropic medium, and it only goes in one direction in time. I was like, that's like a eureka moment, right?
Yeah.
It's like, aha, that's how it works. Yeah.
I think most of us will have to think about that one, Chris, to go,
I
aha.
wonder that diamond that is seems to be actually based on the triangle structure, what is created out of the circles and the square. It comes actually between the circle and the square as the particular lines between the points.
Yeah, so the diamonds, basically the diamond shape is 120 degrees offset when you take the cube, which is 90 degrees. So what we're looking at there, magnetically speaking, is the Birkeland currents and Meissner scalar waves. So you got scalar waves that go in straight lines, and then we have normal oscillating waves.
Are you showing us something, Chris? Are you showing us something?
No, I'm just talking, yeah.
Oh, okay, sorry. I just wondered because I could just see your icon. Carry on, sorry.
Yeah. So the icon actually kind of explains it too, but you end up with a fourth dimensional object because we have straight line scalar waves in a linear sense that follow 90 degrees and 120 degree offsets. That's what creates the light focal point. And all the crystals that kind of focus light in one direction is polarized. It polarizes the light towards us. And then once that polarized light, which comes from the plasma gases, once that hits our refracting atmospheric dome over the plane, everything comes towards us, and that's why we get that flip-flop of the moon image. Like once it crosses the magnetic equator, the moon image flips upside down because you're on the other side of it. But that's just refraction. The refractive index of water in the air causes that effect. Fascinating study in perspective and anisotropic light propagation.
So do we see actually only one actual side of it then also, no matter where we are?
No matter where you are, you see the same face, yeah.
Yeah.
Yeah. But what happens if you, I'm sure Dave will attest to it, if you cross the equator, you still see the same face, but now it flips, the image is flipped. Right, and it just rotates. It's the same side. It just flips, and now it's rotated the other way. But it's the same face facing. But as soon as you cross that magnetic line, it just reverses.
Yeah.
Yeah, because it's following that toroidal path.
So it is actually also the medium where it travels through, or what the fields are, what they actually create as the fuel through the medium.
Yeah, through the medium. Yeah, and what I found, when we were looking at the spheres, the giant spheres, the Costa Rica stone spheres that form in the clouds of dust, and then they fell down after the cataclysm. I found in the model I had to change the moon to be about 33% density. It's not solid system of dust, like probably like a titanium, aluminum type of dielectric metals. It's a dust particle system. And that's the only way when you can get that the proper reflection on it, and it makes it look like it's flat, but it's not. Like, so the shadow will have that funny, it'll curve in real sharp at the top, and then kind of go flat across the center face, and then curve again at the bottom, and you get that silvery side on one side, like on a half moon, it'll be silvery outside, and you don't have a center glow, like what they call a crepuscular ray glow in the center, like you would on a sphere, a solid sphere. It should have if it was actually solid, you would have that glow in the center of a ball, like if you shone a light on a basketball.
Yeah.
And we don't see that when we take pictures. So properly in the screenshots, I had to change it to a semi-transparent solid. So that might help Dave out in his research to see if he can confirm some of that with the photographs and telescopes and things. So
yeah, particularly the light point that you see also on the moon, in the light side, you see that what I can see through videos, it's kind of with all the blurring. It's kind of as if you're looking into a universe, but the darker side shows up particular of these particular points as well through this particular electromagnetic effect on the moon from within itself.
Yeah, and yeah, you're right. It's like you can almost see through it in certain places and certain angles. And Brad Gillian and I, we did some research into that. And I think Dave might have seen that on my Facebook, where we looked at the chromatography of the moon from a metallic standpoint. And we ended up seeing that the colors, when you crank up the saturation, you can see the temperature gradient in the metal. So at some point it was electrically hot and it was anodized. Like some of those craters are actually purple and gold and green, and so it was anodized.
Can I ask you
so
something? You're just talking, are you, Chris? You're not showing us anything because it's very detailed stuff and we just got an icon.
I can try and pull up some pictures. Yeah.
Yeah, I think that's best because there's a lot of information coming out. I mean, I've listened to it a few times myself, but there's a lot of information and maybe people can't.
Let's see what I can find here, but maybe Dave could kind of take over while I Google up or bring up some pictures from my other posts and things.
Yeah, like Siri's just said about when you shoot the moon, say it's a half moon or like first quarter. What you will notice is you'll get a really sharp edge near the terminator edge, where you'll get a really good picture. But then if you look at the rounded side where the disc or the shape of it is, you'll notice it's like a blurry. You can never get a good focus on it. No matter if you just concentrate on that spot, it always looks blurry. You know what I mean? It's the actual, whether it's the medium it's going through or the angle or whatever, you can never seem to get a nice sharp image on the actual circle side of it. But like I say, as soon as you get your camera on that terminator edge, you've got lovely, crisp, nice, clear shots. Especially if you're catching in 4K, you can really see the detail. But it's impossible to get a nice, sharp image on that and on a full moon as well. That's why I never bothered shooting full moons, really, because they don't look very nice actually when you capture a full moon. There's no detail there to see at all. It's basically just like it is on the edges, like, you know, away from the terminator edge. So that's interesting, like I say, and I'm not sure why.
You could what? Because at full moon, the moon's so bright. That's all you see is bright.
No. You see the shadows, but there's no features on the moon like the craters or anything like that where you can actually see on a full moon. I'm sure if you get your camera and you film a full moon, what you'll see the dark patches and the dark places where the craters are, but you won't see no detail whatsoever. When you get like a half or quarter moon, you'll see the actual depth in the craters. You'll see the shadow on it. You'll see the lights. You know what I mean? You'll see everything. But on a full moon, it just looks like it's, well, the phrase waxing is a perfect name for it, because when it's waxing, it basically looks like it's melted wax. You know what I mean? You imagine melted wax. Yeah, and you've got the moon as it gets full. There's just no detail in it whatsoever. Like I say, it'll look pretty sharp, but there'll be no actual nice detail.
Did you hear Preston the other day? He was on. He's another person that likes the moon like you, and he takes lots. You know, that's how I found him, because he was talking about how the moon worked. You know, he was just someone that one day realised by watching it, oh my goodness, all this was happening. Anyway, he was saying. Did
he thank me on Facebook the other day for sure? I showed him that basically what the moon cycle was doing over the year. Like, I think he did a post where he says thank you for showing me. Yeah, I know.
Yeah, you get mentioned rather a lot on our Hangouts now. There's always a Dave Marsh mention now. Series mentions you. We all mentioned a lot now on our Hangouts, Dave.
I think a couple of these pictures actually might be your pictures, David. You might recognize a couple of these.
I've got about 4,000 on my computer.
Yeah, no doubt.
Recognize.
Yeah.
Well, yes, then that although it looks like it's textured and it's things, it's actually, you know, it's kind of smooth. There are no real craters. There's sort of
Well, the craters
depth in a.
the craters are there. But it's because it's semi-transparent that as the light travels across the surface, then it diffuses into the dust, right? Because it seems to be a semi-solid. So you'll see the craters only show up in the shadow line, and then the rest just it absorbs the light. And so what Brad and I found out was when we cranked up the saturation, so it's not Photoshop, we just increased the saturation in the photos. And it's like Dave was saying, in spots you can almost see through it. And then I just scaled it relative.
Cosmic web.
Well, exactly, yeah. So, and then I scaled the colors relative to voltage for titanium and aluminum anodizing. So you can see that, you know, this area where it's really dark was either, you know, around 30 to 40 volts, and the golden sections were higher voltage. So they were exposed to an electric, you know, a hot electric current at some point. And if you really crank up the saturation, you'll end up with greens, right? You can see where the greens and golds are. And that tells you what the voltage was that changed the color of the metal. So it looks to be like a metal powder that was hit with electricity. You know, so there are craters. It is semi-solid, but it's a giant dust ball of metal, as near as I can tell. I mean, that's the latest research I've got on it.
One, and it's all just in the actual by the density, is it, of the actual medium kind of thing?
Yeah. Yeah, exactly. Yeah. Yeah. So
that would make sense, and that's why the moon would actually be around as well.
Yeah, it's a big dust ball, basically. And so the electrostatics would make it a sphere, and you can actually see through it in certain places, right? It's a floating collection of metal, a lot of it. That's a lot of metal, but it's still semi-solid.
Yeah, a lot of people try and point out that the moon's not actually facing the sun. You know, when you see it say you see the moon rise and you see the sunset, what you'll do, you'll see the moon rise on its side, and obviously they'll say, "Oh, look, that's pointing upwards." It's not that, but that's just a perspective thing. That the lit side is always facing the sun. We need to remember that. Like I say, even if it doesn't look like it is, it's still facing it. So,
absolutely, yeah. That's too. So it's also why sometimes I think if you get the sun on the right angle, you'll see the moon almost appears to be backlit, because you'll see it bright on one side, and you can still see the other part of it glowing, but on a lesser diffused, right? So the light's actually penetrating through it to a certain degree.
Yeah, I've got quite a few shots of that. It basically lights up the shadow side. You can see the full shape of it, and you can actually see the actual shadows inside it if you look carefully.
Yeah. I'd like to see those. If you have some of those, if you could send me a few of those, I'd like to see those. If you could see that inside shadow, I could probably calculate the thickness of the density of it. Yeah.
I'll tell you who's got the best one of that I've ever seen is Alex Korean. So if you just search for Alex, you probably know who he is, don't you? Yeah. Rethinking the Universe. Have a look, because he took a picture with his telescope using his Nikon D500, and it's absolutely perfect. You know what I mean? Just the right amount of showing on the actual moon, the actual crescent. Just a tiny little slither it is, and it just lights it up perfect. Like it's a great shot. But he reposted it a few weeks back, actually, because it disappeared for quite a while, didn't it? And he's just like reappeared, and he reposted that image, and it is one of the best images I've ever seen of the moon. To be honest, it is really, really good. But Chris, I've got some, like I said, what I've been doing lately. I've been capturing the moon in 4K and then taking a frame from the 4K image, and you do get some serious detail in it. Some people have said, "Oh, you started stacking your image, Dave?" I said, "No, I'm just taking a frame from the camera." So maybe I can send you a few to an email address so you can get the full quality as well, so you can have a little look at them. Because, like I say, I've got some good ones. Full moon, waxing, waning. I just haven't got any crescents yet because I haven't seen the moon, a crescent moon, for quite a while. So, but when I do, I'll send them to you.
Say something. There's a question from the chat room, SH700R. Anyone on the panel ever think that the moon is the old sun burnt out?
No, I don't. I know Wakey's mentioned that in his book, that it's an old burnt out sun in his flat Earth moon book. But me personally, I don't think it's a burnt out sun. That's my own opinion.
No, I don't think so either. No, it's a metallic structure, dielectric metals, and it'd be in a static field. So it would be, like I said, semi-solid, and partially hollow, perhaps because of the static electricity involved. But the sun's based on helium and noble gases in plasma, so it's the opposite, totally the opposite polarity.
Also, if you check out Cass Kring's page, he's got some great video of the moon where he reduces the actual contrast and messes about with all the levels, and it basically turns the moon into like a cosmic web, and that's a brilliant video of that. So if you ever get a chance to nip onto his page, yeah, I ain't seen him around for a bit quite actually. I used to talk to him quite often, but I think he's dropped off Facebook a little bit. But he has got some really good videos from a couple of years back, I think he were, where he reduces the levels, and you see some really interesting stuff through the moon. So that's probably worth a little gander at.
Excellent. I'll check that out too. Because what I'm trying to do now.
I'm interrupting a lot tonight.
Yeah, go ahead, Karen. Yeah.
Well, I was just going to say, as it's metal dust, so it's like it's got to be, is it like a pendulum then, after all?
It's, the pendulum is just referring to the north and south declination.
Well, I mean, as it's a lump of metal flying through the semi, whatever it is. Oh, actually, no, it is on the inside. You said it's on the inside of our whatever firmament or whatever. So, and being metal, is it magnetic? Explain for the
it's the opposite. It's the opposite. It's a diamagnetic, so it's being repelled.
Yeah, so it's repulsion. It's not the attraction. It's the repulsion side of it.
Right.
So it's been being pushed instead of pulled.
Oh.
Exactly.
The other side of the magnet.
Exactly.
Yep.
That's what I was getting
when
at.
you take two magnets against each other, what you do, you'll feel like a little ball when you rub them together. You know what I mean? It maybe something related to that. I mean, I'm not 100% sure. Like I say, I haven't really gone into a lot of detail on what the actual moon is, to be honest. But I think Chris might be barking up the right tree there, actually, because it does make a lot of sense. It's definitely reflecting something, or a lot. I know a lot of people say it emits its own light, but it does. It is. Is it just a coincidence that lit side is always facing the sun, even when it's on when it's rising, and it doesn't look like it is? It actually is like it's just from our perspective. Because remember, when that moon rises, we're viewing it from a different part of the plane. Yeah, when it gets to zenith, that's when it's at. You know what I mean? If it was at zenith and the sun would out, you'd notice it would probably be in line with it, if not a little bit out with the sun setting. But then, you know what I mean? You need to understand that it's just because it's out of your view, your field of view.
That's
exactly it. Yeah. Well, I'm sure some people have seen that experiment where they, you take the aluminum and you freeze it with liquid nitrogen, then you take a magnet and put it underneath it, and it'll rotate in a circle, and it locks into that circle, and you can tilt the little magnet, and it'll go around in a perfect circle.
Different angles. That has to be really super cool, doesn't it?
Yeah, super cool. Yeah. So the moon is in that happy zone of where it's actually super cold, because when the balloons go up, they get to 110,000 feet, and it drops to like -72, and then it goes to like minus 150, and then it starts to get hotter. So the moon is in that layer where it's super cold. So it's an aluminum superconducting dielectric powder. Right, so it's locked into that field stationarily, so it's locked, and that's why it's always facing us in that certain direction. It's never going to, and it'll just kind of wax and wane, right? It'll just kind of rock back and forth in that dielectric field, and the dielectric field is coming from the oceans and the salt on the Earth's surface. So it's and that's why we get the change in tides, because as the moon passes over, it interferes with that conductivity. So you see a fluctuation in tidal heights, but only in ocean waters, right? never in fresh water, just salt water. So the moon's definitely locked into that dielectric current. Yeah.
And that's actually where the word lunar comes from, because it does actually affect the human beings as well. You know what I mean? We've got salt and fluids in our body too. So when you do get like a full moon, it will actually, it has been known to obviously change your mood or your feeling, or even send you a little bit crazy, because that's where the word comes from, lunatic.
Yeah.
So.
Yeah, that makes sense. Yeah, it's you know, any major change in the moon's elevation would definitely have an effect on our bodies, and you know, we would feel different pressure. That type of thing. Yeah. And I'm sure it does seasonally too. It does the analemia, right? So I'm sure people that have seasonal affective disorder, that could be, you know, part of that type of process, electrical, right? Because I mentioned before, I know that, you know, if you move to a location on the magnetic map where it's more dielectric, your blood pressure can drop, right? I noticed that when I was flying all the time. Like I'd go out west in the middle of Canada, it's the plains, right? It's just this flat plain for as far as you can see. You know, the old adage is, I lost my dog, I can still see him running, but he's been gone for 3 days, I can still see him running away, right? It's that flat, right? Yeah. But anyway, it's the plains Canada are basically on top of an old ocean bed, right? So it's a lot of salt, like a ton of salt, and underneath that, of course, is oil, but it's all salt plains. And I noticed when I went out there that I had problems with blood pressure, right? And it just messed me right up, because I'm from Atlantic Canada, which is iron rich, right? So I'm used to that positive pull. I like the density, and when I went out there, my blood pressure just went through the roof. Okay. Oh yeah, yeah. I had blood pressure problems, and my heels hurt, and you know, I was just all messed up. But now that I'm back to Atlantic Canada, where the iron is, I feel normal again, right? Yeah.
Yeah, I'm back in a sec. Just going to nip upstairs. 2 seconds.
Which is fascinating. I find all the flat Earth research it'll lead you in these directions, and you'll come to these conclusions, and people can learn a lot, which is why I support it. Yeah.
It's the cherry and kind of the hub between all the information.
Yeah. It's the key, right? It's the key in the door to unlock the door to, well, there you go. Here's the answers, you know, at least part of them. Not all the answers, but, you know, a great majority of the answers. Yeah.
Well, yeah, the center of the vortex into the information. You know, before it, you don't have it. After that, it gets more and more and wider.
Yep.
The toroidal field.
Well, that's the key, I think, is you got to stop your head from spinning first before you can actually focus on the center, right? That's the problem with the globe. Everybody's heads are spinning around in circles, and they can't dial in on a target to even come to any sort of a conclusive thought process, because it's always a circular reference, round and round and round and round and round. You never get to an answer.
No, I noticed when I was married, a husband of he had to go to meetings, but they had a meeting to have a meeting for the next meeting. It's just meeting upon meeting. It's just having a meeting to have a meeting.
Oh yeah, the corporate game. Yeah, yeah, yeah. Those corporate meetings, I guess, is what you're referring to.
Yeah, just always, you know, it'll always be another meeting afterwards.
Yeah.
You get anywhere. Oh, you're back now, Dave.
Yeah, I just want to make a little announcement. I'm sure a few of you are going to the meetup tomorrow. Are you?
Yeah. Are you going?
Yes, I'm going too. So I'll be there.
Yeah, I'm gonna meet you tomorrow then.
Yeah, I'll be there. 12 o'clock. Maybe a little bit after.
Chat room. Did you hear that? Dave's coming.
I'm bringing Susie's dad. He's a flat earther too. So
wow,
you get to meet
this will
Susie's
be.
dad.
Oh, this is meeting like members of my group.
Yeah.
Group coming together.
Yeah, like I said, I've met quite a few people already. I've met Dave Moore, Darren Nesbitt, and all the Fukas. I've like been out for drinks with Simon Rennick and a few other guys like so. I've met quite a few, and like I say, it keeps growing and growing and growing. Every time one of these meets, first time there's about 10 people there, second time there's about 50 people there. You know what I mean? So it'd be interesting to see how many actually comes to this meetup, because it looks like there's going to be quite a good crowd there.
Yeah, Gary's coming.
Yeah, although the weather, I said it might be a bit drizzly, a bit cloudy, a bit drizzly. So we'll have to just hope the weather holds off. But yeah, I'm getting picked up tomorrow morning at 9 o'clock. And
weather won't matter, will it?
It won't matter, no. And also, I don't know if you saw the response to the Can of Arts meme. Basically, we did a bit of a collaboration where I asked him if he could make a meme from a moon race video, and I gave him a little bit of a concept drawing. I don't know if you've seen the drawing I gave him. It's quite funny actually. It looks like my son actually drawn it. But anyway, we got together. It took him quite a long time. Like I say, I think he's been doing it for about like a month before, and he kept giving me updates on it. Got some great images where he first did the concept and started shading it in, and then they sent me the coloured version. I just wondered if you all saw it, because it was quite a good meme, wasn't it? I thought it was brilliant.
Yeah.
There was quite a lot of comments on the actual meme as well, because he started a bit of a division between the circling sun and moon and the square map. Like it was like World War III on there. I was sat there with my popcorn. It was quite funny. Even my missus was watching it when she was coming back from a holiday. Like, So, but like I say, I had a good response. And. Cam was a little bit worried at the time, but
do you find that even though you've got this data and you know that you've done these experiments, it's still hard for people to believe you?
Yes, because like I say, I've heard every excuse in the book. I've heard like I say, it's down to parallax. Oh, you haven't been to the other location, so how can you record it from the other location? No, I haven't been to the other location, but I've shot the data from my location and compared it with mainstream time and date and mooncalc, and I presume if I went to the other location in New Zealand and took observations there, they'd probably match up. The meridian passing times will probably match up with what I'm doing. You know what I mean? Why would they be different in the UK than they are if I was stood in Auckland, New Zealand, taking readings? You know what I mean? Remember, I'm timing the moon's culmination as it passes that zenith, and then repeating the process on the following night to see what the time difference time scale is. That's how I'm measuring the speed of the moon, and you can't hide that. And you know what I mean? They can hide certain things, but you can't hide that meridian passing, because imagine like if you did point your camera up when it was south, and then you went, oh, I think I'll just check time and date to see what their readings said with my area and at this exact time, and it said it was in the southwest. You know what I mean? You start asking questions, won't you? So it has to be exactly where they say it is from your location. And 9 out of 10 times, it's nearly spot on. Maybe 2 or 3 degrees out, but that's just because I'm using an app on my phone, and you know what I mean? I haven't got the equipment what they've got, but normally it's within about 2 degrees. And can you give and take a couple of degrees? I think you can.
Dave, Robert, are you there? Robert? He was driving. He's been away, right? He goes to Myrtle Beach, and he has taken, so every day he's dawn till dusk, and he's gone to visit his son, which is inland, but there's still a big amount of water. It's just that he's been using some of his apps, and they just don't correlate. So he's been measuring things, and all the apps say different things, and none of them match up, and he was a bit shocked, really. So basically, there's a lighthouse there. So he was actually further up on the ground than he was in the lighthouse on one of his apps. So the lighthouse should have been the taller thing, but it wasn't on the ground. So anyway, I was just hoping he'd come in because he explained.
an object when it's further away will appear smaller. You have to set that into account too.
No, he was just going for the altitude of where he was, like on his
Right.
phone. He just
Right,
wanted
got
to
you.
see if they all matched up, and they didn't.
Well, every single reading I've ever took on Mooncalc and time and date has always matched up with what I'm shooting. Like I say, you know what I mean, I've got a really steady hand, and sometimes it's not smack bang in the center of the moon. You know the moon when it's on your phone screen, it's like a little tiny dot. So, but you know what I mean, you take a shot, you think you've took it in the middle, you have a look at it, it's quite a bit out, like, and being quite a bit out can be like 10 degrees, but normally I take a 2 or 3 shots and try and get it in the center. Not every time, but like I say, it normally matches up with time and date. You try it for yourself. Go and take a picture of the moon when it's out. Click on time and date. Look at the moon angle, and look at the altitude and the azimuth, and you'll see it's pretty much what you're shooting. Like I say, I showed it in the moon race video twice, on the first time and the second time, and all the readings always match up. You know what I mean? Altitude, say 40 to 49.
That you've given series the next 100 years of moon rises, and they know.
Yeah, I did the same thing. You may have seen it on my Facebook there yesterday. I think it was. I went out in the morning and I took an eyeball on the moon, and I could clearly see Venus with the naked eye. It'd be around the 11 o'clock position above the moon, and I could see the Venus even with the naked eye. I could tell. I squinted and I looked real hard, and I could tell it was in a crescent shape. It wasn't a full circular object either. So, and then I came in, I ran into my model here, and I went to the map, and I took the camera and I put it bang on at my coordinates on the map. I went to Mooncalc that Dave showed us there, the demo of there last week. And so I used its coordinates. I raised the camera 32 degrees, and I pitched it 93 degrees to the south, and bang on, there was the moon right there in the image. Right, so it's spot on with the square flat map. Yeah.
Yep, and like I say, it's the kind of information, like when you're doing the moon culmination, the zenith crossing, you just can't hide that kind of information. You know what I mean? On the sun calc, they only show the solar day, so it's quite difficult to do on that. But with the moon, and like I say, because the moon passes from tropic to tropic every 2 weeks, it's so easy to, you know what I mean, see the actual difference and see it rising in the sky and see it at different positions. Like I say, with the sun, because you're only getting a very, very small movement north and south every day, it's very difficult to see it. Like I say, it takes a year to see the analemma, where the moon, you can see it like in a lunar month, you know what I mean? So it's, like I say, the moon dates, I can honestly say that they are pretty accurate with what we're shooting, even though we're using crude lit things like apps from Android and iOS. They are still pretty accurate. You know, these GPS apps and all that, they are pretty accurate. You know what I mean? When I switch the GPS on, it's normally pointing in somewhere within like house, so it is pretty accurate.
Yeah. Square and stationary. Yeah, she's dead on. Yeah. Yeah.
Exactly.
Yeah.
Yeah, and to just say something that maybe, well, I'll put it as a year ago, you two, didn't you? You thought that was the right map, but it isn't.
Well, obviously, when I first went to Flat Earth, the first thing I saw was the azimuth equidistant map. You know what I mean? And it felt right for me at the time. And like I say, I knew there was like some issues with it, and certain flight paths which would be impossible on that map. Like I say, because what a lot of people were doing on that map as well is they was drawing straight lines from one location to another. On the azimuth equidistance map, you can't draw straight lines. You have to follow the lines of latitude if you're going to go from one, say, from South America to Africa. So people are just drawing straight lines across it. It doesn't work like that. And remember, that map's just a projection, and you need. It's very difficult to read and understand that map. And I think you need to read Alex Leeson's book to actually understand how to use it, because because of the continent sizes, it has to be equidistant. Because if it isn't, then the continent sizes don't match up with the lines of latitude. That's why it has to be equidistant like that to reveal the true size of the continents. It is pretty accurate up until the equator, and it just goes pear-shaped. It's just nothing works. And like you say, once I did that moon race video, the first one, I started questioning the map then. You know what I mean? I was like, well, why would it slow down? Because you imagine, yeah, I'm trying to prove to somebody that the sun and moon are circling. I take a reading on the Tropic of Cancer. Yeah, the moon goes at one speed. Then when I take it on the equator and it's speeded up, I'm thinking it's doing exactly what it's supposed to be doing. You know what I mean? Then when you take a reading and it's like way slower, then you're like, hold on a minute, that's not right. It should have sped up again. And when it doesn't, then you've got to say, right, I checked all time and date and moon calc and looked at it and followed the obviously moon when it was on the tropics on the equator, and it was doing the exact same every time within a couple of seconds. You know what I mean? It's not like it does it just once in a blue moon. It's following this same pattern year after year, week after week. You know what I mean? It never changes. It speeds up, slows down, stays the same speed, stays the same speed. Speeds up, slows down, stays the same speed. You can, like I say, I've put all the information out there. Whenever I do a post now, I always try and put all the source data, whether it's something from NASA or whatever, whether it's, like I say, the moon speed. I put every link to every destination that I work from. So if you go to my moon race video and you scroll down, you'll see moon count readings when it's on the tropics, and you also see time and date reading so you can look at the actual meridian passing to see, you know what, they are what I'm saying, because then we could all make stuff up, couldn't we? But if you put
and Dave did it again.
Yeah, like I say, I repeated it again and I got the exact same results. And also I did, like I said, when I did it before, I just did it when the moon was available for me to see. Like, but on the second one, I made sure I did it at zenith, so I had the moon at the exact same position every time I shot it. So that to me then is, you know what I mean, if you're getting the same results every time, I can imagine if I did it again, it's quite difficult to do it this time of year, but if I did it again, I'd get the same results, and time and date and moon count will confirm that as well.
Yeah, and I think you're a bit shocked, weren't you? Because you were kind of expecting it to be this map.
Yeah, it would need to speed up when it leaves the equator to go to the Tropic of Capricorn, and it doesn't. It slows down. It does the opposite. How could that work on that map when it needs to cover more ground as the circle gets bigger?
I did a video today, right? It's not that what I'm filming is my research, it's someone else's, because it's them taking the pictures. But I just wanted to explain to people that anyway, Dee went with his daughter down to the beach. They both took pictures of the sun, or standing there, and the sun came to her feet, but not Dee's. But when Dee looked, the sun came to his feet, but not his daughter's. So these are experiments you can do yourself. Go to some water, have hopefully the sun shining down, and have two of you in two different places to see the sun coming to both your feet, but not the other ones when you're looking. So that's something you can do. We're not as probably but determined as Dave as a photographer, but you've done your own research, so you know, don't you? So
well, yeah, and like I say, I put it out there so other people can say. I'm not telling, yeah, that is the truth. I'm just saying, look, I've presented you something. I've given you the source data for you to actually look at it yourself. I'm not asking you just to click on the video and enjoy the video. I'm asking you to watch the video, look what I've done. You know what I mean? How could we record the speed of the moon? You know what I mean? How could we do that? What would we need to do to actually do it? And like I say, it's not a precision experiment, but it's the results actually are matching up with what time of day is doing. So it is pretty close. Like I said, there was a bit of a discrepancy on when the moon was on the Tropic of Capricorn, because what I'd identified is that when the moon's actually further away, when it's got declination further south, it is actually the radius of the moon is shrinking. And so you imagine you've got a smaller image of the moon on your screen, it will take longer. And screen, I actually overlapped the other moon when it was on the equator to give it a bigger size, and I actually took that into consideration, and it was actually 12 seconds difference. And I actually mentioned that in the video that I had noticed that the radius of the moon had reduced. But the funny thing is, when it's east or west, rising and setting, it grows. It does the opposite. So you're getting that atmospheric lensing when it's east and west, but you're actually getting the declination when it's further south, which is strange, because I would have thought that because you're viewing it through more layers of atmosphere, it would actually stay relatively the same size. But clearly it's not. It's shrinking. But that doesn't compensate for the difference in times. It's not further away and moving slower. Say if you went to New Zealand when it was on the Tropic of Capricorn and it was perpendicular with the observer, yeah, and you shot the moon, it would still be doing the same of what it's doing where I'm shooting from here, because the readings I take for the culmination of the moon from both locations is within a second, 2 seconds of each other. You know what I mean? It's doing the exact same there that it's doing here, and it's not a perspective thing or anything to do with parallax.
Did you see the moon this morning? It came up in front of the sun.
Say again.
I said, did you see the moon this morning? I bet you didn't, or maybe we're going to work, but the moon was in front of the sun this morning.
Oh, was it? Yeah, it's not far off being a new moon, is it? I think it's going to be a new moon in a couple of days. I haven't seen the moon for a little bit. It was out the front the other day, and I took a couple of shots of it, and that's about it really. And obviously, I did
we've grown up thinking that the moon is the nighttime thing, but it isn't. Half the time it's in the day.
Exactly, yeah. It's only when it's very, very close to the sun that you can't see it. So, but yeah, you see it all the time in daytime.
None of us grew up thinking, oh look, I can see that. Maybe we did, maybe we just didn't. Maybe it's because there's this we've been told it's the night time. It rules the night, it's night, but half the time it's in the day, or it's not.
Yeah,
there.
when it's waxing, it's out all afternoon, isn't it? You know what I mean? It's out nearly all afternoon, and then after full moon, it's out all the morning. In the morning, then like when it gets to waning, so it spends half its time in the afternoon and half its time in the morning, which makes up the day, isn't it?
What I noticed last year when I was monitoring these things myself, you know, like when you start looking at these things and seeing what happens, sometimes the sun or the moon would come in fast, hang around, go off slow. Sometimes it would come in slow, hang around, go off fast. Sometimes they come in faster, go off faster, slower, and it just hangs around forever and goes off slow. So it's always changing.
Yeah, what I've noticed about the moon as well, when it's waxing or waning close to the equator, you don't get much actual rotation due to perspective. It basically just hangs there, like you don't get hardly any rotation at all from the field of view. Like it basically just normally it go like that when it's high on the tropics and that, but on the equator it just seems to does go a little bit, but it just very, very slowly. I've noticed that quite a lot as well.
Yeah, and I think also it was another thing that you've researched, and we're very thankful for having Dave Marsh and all his research, because he is another person that puts many, many hours into this, and he works, and he's got a family. But it's the 13 moons a year, which a lot of people don't know about.
Yep, like I say, it travels north to south 13 times faster than the sun. So in reality, it will cross the equator 26 times a year. Like a lot of people think when they look at the AE map, I don't know why they think it, but they think it's always opposite the sun. And some of these models you see with fancy graphics and that, when you see it completely opposite the sun, is completely wrong. You know what I mean? How would you see the moon in the daytime if it was opposite the sun all the time? It'd be impossible. And like I say, I know that a few people have said about the moon jump. Well, obviously it's going to jump when it's traveling, when the sun's taking 6 months to get from tropic to tropic, and the moon's doing it in 2 weeks. Of course, the moon's going to look like it's jumping from north to south, because it moves, it shifts that fast. You know what I mean? If you imagine when it's coming from the Tropic of Capricorn and coming closer to the equator, but it's still obviously rising 50 minutes later each day. It will appear to keep jumping. You know what I mean? I think Tyson did a good explanation of that, and it's just that speed it goes from that pendulum swing north and south. What makes it appear to jump? But I've done quite a big write up on that. Quite a lot. I think it was about last year, just to try and explain to people the reason why it jumps, because they see it. Oh, it rose at I don't know, 80 degrees. Yeah, but next day I couldn't believe it. It was at 60. That's because it's coming further north, and it's getting higher in the sky, and obviously it's getting further left.
I think that's the bit that freaks people out, because I remember someone put a video up because they were going, I came down here a few days ago and the sun was there and now it's there. It's just this realization that what's really happening around you.
Yes, and like I said before, whenever it's in the winter time, whenever it's a full moon, yeah, the full moon will always be high on the Tropic of Cancer. And then when it's our summertime, like it is now, it's a full moon, you'll notice full moons further south at apogee. So you know what I mean, and that changes through the year. It gets closer, then it crosses. You know what I mean? Then it repeats it. So you can never get a full moon on the equator during winter or summer. It can only be round about the equinox time. And that's why in March, when I shot the moon on the equator, it was full.
Yeah.
Do you understand that?
Yeah. The right one.
So
Right cycle.
if you take the Gregorian calendar out of the picture and just concentrate on the moon, you'll see the pattern. It's quite a simple pattern when you're seeing it. Always furthest apart at full moon, always come together at new moon. That's why now, because the sun's high on the Tropic of Cancer, the moon's like jumping higher and higher and higher every day till it's gone to new moon again. And as it's waxing now, it'll be waxing further south, and it'll be dropping and dropping. You know what I mean? Until it gets to full moon again, which will be quite far in the south. And it's just that cycle repeats itself. And as the sun is dropping on the dropping towards the equator, ready for the autumn equinox, you'll notice that the moon will be relatively full on the equator. Then there'll be a crossing point, and then it'll change again.
So Chris, are you there?
Yep, I'm here.
So when Dave's explaining all that, what's happening with these toroidal fields then?
That's exactly what he's saying is precisely what the toroidal fields are doing exactly. I can turn off the some other stuff here so you can actually see it. Of course, it messes up the moon, because in order to see the fields moving, you have to turn off all the atmospherics. But if I turn on the moon Taurus, and then I zoom in, so there's the moon map, and you take the moon and you take the moon Taurus. I'll zoom in a little bit there so you can kind of see them. And you'll actually see the flop too if you rotate it. So you'll see in the top one, the toroid is actually dragging the moon in the magnetic field. And then the bottom right-hand corner, you'll see the moon reappear as it comes around again here into the camera view. It'll pop up. So that's exactly what we're seeing. And of course, if I take the sun and rotate the sun, you'll see the moon go through its phases. right? If I rotate the sun, so there's your waxing. Or I guess, yeah, that'd be the, I don't know, Dave could tell me, that's the waning or waxing.
Yeah, when it's after a new moon, it's waxing.
Yeah.
Yeah.
So there, if I go underneath.
Then it's waning.
Yeah, so underneath, when the sun is underneath and the moon is overhead in that position, then you get the new moon. It goes black, right? And then afterwards, it would start to fill in to the waxing moon, right? And then it's all relative, right? So the other way around, it just flip flops. So that's why you see first a waxing moon and a waning moon. So one's a crescent shape and the other one's more of a donut shape. Yeah. That's because the sun's going around relative to the moon. But the moon itself is actually being carried.
It's gone black, Chris.
On the y-axis. Oh.
It's gone black.
What it's
My screen's got stuck.
Sorry, Dave?
I'm just saying my screen's got stuck. I had clicked Chris's explanation, but I couldn't actually see anything. I thought it froze like, but when you said it had gone black, I can obviously see now it's froze.
Yeah, there he is. Hang on. I'd have to present. Oh, I've got your icon, Chris, but if I click off, I can see your picture. You might have to present it again.
There, try it again. There we go. Looks like it's popping up there now. Yeah.
Yep.
Yeah, so if you take the toroidal field and then I rotate it on the y-axis, you'll see it. The moon is carried in that field, and it'll actually go in and out of your view, obviously. But yeah, so the moon is going in this direction, and then when it's in the camera view, and then if you jump out of that and rotate the sun, then it goes through its phases, right? So when the sun's below, it goes into the new moon, and then everything else. So what I can do is I can rotate the sun in any position I want it and situate the moon. And then when we turn the atmospheres back on, and the cube, which is the anisotropic space, and I'll turn off the moon-Taurus field so you get a clear picture of the moon. Well, the moon will come into its crescent. And then if I rotate it in the right positions, you'll see I can actually reproduce. There's a blood moon in the morning, right?
Cool.
That's because the sun's below the horizon and the moon is actually just rising in the west, and you'll see a blood moon. Right? Yeah. Yeah. So far, I think this model is working out 100%. From everything I can see so far.
Amazing. I think it was Stan in the chat room asked if you would play this, so I'm going to send it to series. Get through the Hangout. There's a link there. Do you want to see what that is? Faster than mine. Mine, the Hangout just takes a lot of the bandwidth. In the Hangout chat, I've sent a link, and Stan, I think it was Stan, said, "Could you play that?"
Video is private, or it doesn't exist. Oh, it's off a URL.
Let me get back and see if I can get it off the chat. I've gone past it now.
Yeah, I'll put Sun Taurus too.
Oh, well, that's from the chat.
So that is based on the readings, just so everybody knows in the chat that this model is based on the readings that everybody in the Moon and Sun group did over. How long did it take? 2 years or a year? Everybody was tracking the Moon and Sun in that map. Karen?
It was about, I think it's well over a year, wasn't it? The Moon
the readings?
Yeah.
They've been going since about October, November last year.
Right, so this map is the overlay that I based the model on, and then so that's the
just to explain to everybody, in that picture, the yellow ones are the sun, the blue ones are the moon, and the purple ones are Polaris. Blue's in there because it's Jupiter, and there's another color, but I don't think we can see it. Like an orangey colour. Yeah, that's orange. That's Venus. Yeah, carry on, Chris.
Yeah, so that's based on that map, and then when I turn the magnetic field of the moon back on, and then I rotate, I'll grab the moon again, and I'll grab the magnetic field again. Oops, this field and the moon. And then when I rotate them on the y-axis, you'll see that the readings will line up. So the moon is in that magnetic field, so that's why you get the slight flip-flop. So it'll cross the equator, like Dave was saying, right?
But all those lines are straight, aren't they? Because that's taking it off of Google Maps, which is panned out. All the lines are straight.
Right.
So for anybody that can see any
so you can see
arcing ones,
because the moon's magnetic,
they have to do that to turn it into the ball.
yeah, turn it into the ball. Yeah, absolutely. But you can see that because the moon's magnetic field is slightly tilted, then that's why it would tend to. You'll see that it'll pass the equator, like Dave was saying, 26 times a year because it'll rotate. Right. It'll just do that flop. So that's the annulina. It'll flop back and forth. As near as I can tell, that's what's happening.
Wow.
Does that make sense, Dave? You think that's kind of what's going on?
Yeah. Interestingly, because if you look at the data what I've been collecting now, because what the reason why I'm collecting this data now is because I want to compare it to the heliocentric model to see if, you know what I mean? Because what the moon appears to be doing, it's speeding up as it's actually leaving the Tropic of Cancer to the equator, then slowing down again, but then it stays at a relative speed then until it comes all the way back to Cancer. Now, looking at the heliocentric model, I think I mentioned this before, the moon would need to speed up when it's on its closest approach, and clearly in the sky, when any object in the sky is closer, it will appear higher. So when the moon's closer to us in the north, it appears 65 degrees angle in the sky. Now, the funny thing is that according to the heliocentric model and the readings I'm taking, it's doing the exact opposite of what it should be doing, because surely when it's on its closest approach, but I think that's why they've thrown that 5-degree declination in, yeah, because to me that 5 degrees declination shouldn't actually have a major effect on the actual altitude of the moon, really. If you think about it, if you look at it on a scale model, yeah, it looks quite high when it's at the actual scale distance, but would that really cause that shift from tropic to tropic? I don't think it would. The shift is because it's perspective and it's closer and higher and farther away and lower. Yeah. That when the moon is high,
I think you're right. You're exactly right.
Yeah. I think what the heliocentric model is trying to do, they're trying to make out,
right.
Yeah, they're trying to make out it's the 5-degree inclination that's actually making the moon appear higher on the tropics. But we know, and anybody who's done any research on perspective knows that any object, like for a good example, when the moon rises, it's low on the horizon. As it gets closer to you, towards its zenith, it gets higher. And then when it's at its closest point, and then as it starts moving away from you, it starts dropping again. So clearly, the heliocentric model is doing the old the backwards thing, where everything they tell you is opposite. You know what I mean? They tell you it's a ball, that means it's flat. They tell you it's They tell you it's when it's bigger, it's closer, but actually it's actually further away on the horizon. So everything telling you is further away. And that's where I've got to up to now.
That would be that's exactly it.
Yeah, and I know that in any model they show you, they never tell you at what point the moon is at the closest to the Earth. Yeah, because they don't tell you that, I can't compare my data with that. Even though I've like looked at models where they said they've used NASA's data, it doesn't tell you when it's at its closest approach. You know what I mean? Obviously, it should be at that point as it's leaving the tropics and moving further away, but it's not. Its closest point should be as it's approaching, going to the point closest, where it should speed up. If you imagine something getting closer, it should actually, the rotation of the Earth should actually speed it up till it's actually past perigee, and then it should start slowing down in its orbit. But that's when it's speeding up in reality. So it's doing the exact opposite, which doesn't look good for the globe, and it doesn't do anything for the circling moon at all. Because, like I say, when it leaves the equator and goes to it must speed up on that model, and in reality, like with all the data I've collated and presented, it's not doing that. And anybody who's seen that video, and there's been some big names who've seen that video because a couple of them commented, they've got no answer for that whatsoever, because the data is there for them to look at. And I can imagine some have actually looked at that data and just basically brushed it off the shoulders and thought, I'll carry on, you know what I mean? Completely ignore the data I've presented. Yeah, I think some people have actually took notice, and like I say, and I think they might start scratching their heads a little bit. I know a few people have, like, to be honest, there haven't been really that many bad comments on the video, or people calling me a liar, or saying I'm trying to deceive you by showing this and that. So, you know what I mean? I'm only documenting what I'm observing, and is it a coincidence that it's matching up with mainstream moon culmination? No, it's not. It's not.
Yeah, with our stuff as well, isn't it?
Well, it is, because, like I said, the relative change in the moon speed is not as great as it should be, like, you know what I mean? So there's not a lot of change in speed. I don't know the actual. I mean, according to the heliocentric model, there's a 6% change in the speed, but I haven't actually worked that out yet. I'd have to math that on for that.
The way I see it working in the model here is that when the moon is down on the horizon, like we see it as a larger moon, and because it's doing an elliptical arc, so to speak, right? So as it goes over the top, then it would appear, due to perspective, the speed would actually change slightly, and then it will speed up and slow down as it rises and sets and that type of thing. But that's because the atmosphere, which is in here, is a lens. So you'll see the speed change relative to that curve, right? And it's positioned in this arc. And that's all it is. It's just two arcs that are interfering with each other, right? That's
and that's why I shot it at zenith and took all my readings there, because that was probably the best position for it to be in, to actually get a more accurate reading. Like you say, but when it's rising on the horizon, you're going through lots of layers of atmosphere, and it could actually appear to move faster there. You're right there.
Yep, that's what it is. Yeah, it's just a combination of the altitude versus the refraction is what I figure. Yeah, I tried to do some calculations on that too, and I'm getting the same readings and data and calculations that you're getting. So exactly it.
Yeah. Also, there was a couple of comments on. Did you see the video I did about Polaris? And
yeah, there's
been quite a few comments where people said that the camera is slipping. I'd just like to say now that the camera is not slipping. For one start, yeah, the tripod was nearly half the price of the camera. You know what I mean? I got a Manfrotto tripod, which costs, for the price, it's probably one of the best ones you can get. The camera's a medium-sized camera. It's not one of these big, heavy P900s. And you've got to remember, when I zoomed in on Polaris, I was at full zoom. If I breathed near that camera, Polaris would have literally been bouncing around all over the place. Yeah, it was a nice, calm night. It was clear.
Can I say something? David James, you know that he did a video about that a while ago. And also, I knew that it moved a bit because I used to go, last year this was, I stood in my garden and I could work out with the tree, like the tops of the sticking up. And then I started to notice that I could see it had moved a little bit.
Yeah.
Yeah, I mean,
it's got
that's
the rest
a
of the
good.
stars.
Well, that's a good point to bring up, Dave, too, because you know the Polaris is the 1 degree offset, right? However, in the globe model, if the globe is truly at a 23.5 degree angle, then Polaris would actually swing that 23.5 degrees in both directions, right?
exactly.
Right. So I mean, you can't have it both ways. So I laugh when I hear that one. You know, oh, it's you're wrong. You know, yeah, sure we are.
Yeah, I just wanted to set the record straight because deep inside the rabbit hole made a comment on it, say, "Oh, it looks like your tripod slipping," but it's only because I was at full maximum digital zoom. If I'd have done the experiment at 60 times optical zoom, you probably would have just seen a little white dot. You wouldn't hardly seen any movement because, you know what I mean, you have to be really, really close up on it to actually see the movement. If I filmed it for longer, my camera only shot it for the maximum time it could, which was 29 minutes. If I could have shot it for 4 hours, you would have seen the little circle it would have made. It would have made it like a little circle. But basically, you just see it go up because I've only got like half an hour's footage, and you know what I mean. There's not a lot of movement in that. But the camera was fixed, nice and steady. There was no movement, and with the camera being aimed back like that, it was even more comfortable aiming up at 60 degrees. You know what I mean? At that angle, it could possibly just drop a little bit, but it probably a little bounce, but it would have just slipped down like that. When my camera locks in place, it locks, and the only movement you get is if you stamp on the floor near it or you breathe too heavy on it. Because I'm sure if you shot anybody who shot stars, how fast they go from one side of your screen to the other. They're on that side and they've gone in 35-40 seconds. So you know what I mean. Polaris has zoomed right in, and yes, it would have made that circle if I could have left it going longer, but I just shot it just to show that clearly Polaris is not in the center. Yeah, it's 1 degree off, roundabout, and it's moving.
Yeah.
Mm-hmm. Yeah.
And interestingly, the guy I got the original video off, Wide Awake. I'm sure some of you've seen him on YouTube. He's filmed that quite a number of times as well. And I actually put a link in the comments to say, yeah, I'm not the only one. It's common knowledge in astronomy that Polaris is not dead center.
Surely though, Dave, it's only going to be a matter of time before someone actually really noticed Polaris was moving after they said it didn't. I mean, I was reporting I could see it moving last year. It doesn't go right round the sky, but it just moves a bit.
Well, yeah, like I say, it's making the concentric circles.
How they say that? How could they say that to us? It
Well, like I
doesn't
say,
move.
because on some certain models it needs to be fixed. You know what I mean? Fixed in the center. And
what I'm saying
I just wanted to prove that
one day someone like you would have always come along and noticed it was moving.
Well, yeah, like I say, I'd noticed it in the time lapse, like when I did a star trail when I first got my old camera, and I thought, oh, I'll try and shoot a time lapse, and I noticed it had like a little curve on it. When you pull in on the actual image screenshot, I'm pulling on the image because I took like a nice little screenshot of it. And when I pulled it in, I thought, oh, it's made a little arc there. so I knew it had moved, like, but I never thought of it. Then obviously, with all the bickering and arguing and all that over this model, that model, I thought I'd just set the record straight.
Well, glad you did.
Yeah,
It's
I think I might.
helped you understand what series has been doing, and now you can see what series is doing a bit more.
Yeah, exactly. I think he's doing a great job.
This hangout like the other day, Dave. Well, it was a few weeks ago, and it was actually this hangout where this whole thing about the moon having 13 phases happened. I think it was about February, March time. Suddenly, there's this realization that it has 13. It's 13 moons a year. That's the other way around to what we've been taught.
Exactly.
It's just like it's not even that one thing's wrong. It's just everything's like back to front.
Well, if you think about the heliocentric model, they're just trying to work out the math and the physics around the observations. You know what I mean? So it all fits in with their math, but clearly in reality, there's a lot of stuff going on when you start digging deep that you only need one thing not to work, and the whole system,
Yeah.
you know what I mean,
Yeah.
completely kaput. If one thing doesn't match
So
up
13.
100%,
Exactly. Right.
yeah, you can say goodbye to the whole heliocentric universe.
And people in the chat
Solar
room,
system.
I hope you
I'm talking
realise that these are real people, right? Who today know the truth and have worked and are researching and know this stuff themselves. It's amazing.
A lot of this stuff, what we find out, you can't get it out of textbooks or off Wikipedia and stuff like that. You can find out how the heliocentric works on Wikipedia and space.com and things like that, which I've already researched in the past. You know, there's not worth trying to debunk something when you don't know how it works. You need to know how it all works. You need to know that the Earth's at a tilt at 23.4 degrees. It rotates at 1,038 miles at the equator, travels around the sun at 67,000 miles an hour. The sun travels around the Milky Way at 500,000 miles an hour. You know, you need to know all this stuff, like just off your head kind of thing, to realize what the actual issues are. You know what I mean?
Yes, and it's great to see Martin still in the chat room. It's great to see everybody in the chat room, but there needs to be more Martins, you know, more Martins. Where's all the bigger YouTuber people when we're talking about this stuff? What's really going on? And then they all think that they know everything and they don't.
Well, like I said, there's a difference between researching stuff online and actually making observations. Like I say, would I have found out that the moon speeds up and slows down just by looking online? Probably not.
No.
You know what I mean? You have to go out there, observe it, then scratch your head, and then look at the data what's available to you. So, and like I said, that experiment, I know a lot of people call Robotham, but that experiment, what I thought up, the moon race experiment, was a zetetic, which if I had read something like zetetic astronomy, would I have conjured up that kind of an experiment? Probably not. So you have to, you know what I mean? It's these kind of little things, like reading about Robotham. I know a lot of people don't agree with what he wrote, but it's still one of my favourite books, if I'm honest. And like I say, reading this kind of stuff gives you the the actual imagination to conjure up these experiments. Because, like I say,
today, Dave, on a little video, is this bit about, you know, like if people go down to the water, it needs two of you to do it, and you both need to see that when the sun's coming to your feet, it's not coming to the other person's feet, but to the other person, it's coming to their feet, but it's not coming to your feet. Experiment. You do yourselves.
You can do that anyway. Next time you're on a train and you're going along the coast, just watch the if the sun's in front of you, just watch the sunlight. It'll just follow you all the way along when you're going along on the train. So you can do it that way on your own. You know what I mean? That beam will be straight towards you all the way along the coast. So
what I'm saying is, you know, like everybody goes, but what experiments just can the average person do? Anybody do? This one you can do yourself.
Exactly. And the moon race experiment I did, anybody can do that experiment. All you need is an app like Dioptra or Theodolite, what we call it. I don't know what it's called on iOS. All you have to do, is take a pic. Find out what time the moon's going to be at its zenith in your area, and take a picture, and then just repeat it the following night when it's on the tropics and the equator, and just compare your data and your observations with what time and date and moon calc's saying, and if they're matching up, then you know you're getting somewhere. And then all you need is a little spreadsheet and just put a few little dates and a few little numbers in, and you can start building up a little bit of a, you know what I mean, a bit of data. It's not rocket science. It's just basic observations and obviously documenting the information you're finding. Like, so I encourage everybody, especially people in the far southern hemisphere, to get out the apps and do it themselves and say, you know what, let's see if it does actually match up, because you've only got to take 6 photographs in one lunar month and 3 snapshots from time and date and moon calc, and you've got the data for a lunar month to see what it's actually doing. You know what I mean? And I might actually do a video on how to actually do it.
I met Preston. That was the same thing. He was just somebody monitoring the moon himself. So that's how I found Preston, doing what you just said.
Yeah, and he actually questioned me, saying, "Oh, I don't think you're right about the moon being. It's only full when it's in the opposite hemisphere. You know, it's saying summer. It's only in the winter hemisphere." I says, "Well, go on to time and date, and you try and find a full moon in summer above the equator line. You will not be able to find it. It's not until the sun starts moving down towards the equator line that the moon will start moving towards the equator line, the opposite end." You know what I mean? And then he come back to me and he says, "You know what, Dave, you was absolutely spot on with that, because I've spent hours and hours and hours going through different phases, different days, different everything you could possibly think of to see what the moon's doing at different times and what have you. And now, like I say, I'm in the middle of collating a lot of data, which is really, really time consuming. I've got to have 3 windows open because I need to be obviously on time and date to actually work out my time difference, and obviously on moon count to find out where the culmination of the moon is and when it's on the tropics and when it's on the equator. Like I say, it's a long process, but I'm up to June now, so I've gone from December 2015 up to June 2016 from the UK, and I'm going to be doing the same again from somewhere on the equator, Ecuador, and then there's a town in South America, the furthest city south, I can't remember, it's in Chile or Argentina or something like that, and I'm going to use that for my southern reading. So hopefully then, when you see everything next to each other over a year from all 3 locations, and all the times on the equator are all hopefully matching up, and all the times on the tropics are all matching up, then you'll see, from every location on the plane, the moon is doing what we're saying it's doing.
Do you know what you lot sound like, really? You all sound like scientists.
I think when Chris talks, or when he does a post, he sounds like a scientist. He blows my mind sometimes.
And Series, because Series is like he's like a walking computer. You're a walking computer now. Even when on the Hangouts, Dave, you manage to get all the times, the dates, because you're probably remembering them. Don't you remember them all?
What I try and do, I try and remember as much as I can, if I'm honest. You know what I mean? I like to keep a lot of the information up inside my head. I don't like to just write it down and forget about it. I like to remember what I'm doing. It's difficult to remember everything, but you know what I mean? Sometimes I'll forget something. I'll have to look back and see what's going on, but normally I'll try to, everything I learn, I try to remember. You know what I mean? If you do go to these meets and somebody asks you a question,
you guys here are walking encyclopedias.
I haven't got my computer in there. I can't answer that question. Sorry. You know what I mean? So.
No, I'm saying you lot are like walking encyclopedias.
Well, reading a lot. Like I know Dave loves books and reads a lot, and when I was at my peak in my career, even I was reading upwards of 200-300 pages a day, every day, right, for 20 days straight, technical manuals and stuff. And then in my spare time as a hobby, I would read all the Hermes and Trifidiscus and all that stuff, Blavatsky and Steiner and Plato and Socrates, and just read, and then something will click, like Dave says, it will just click. Well, now because he read that certain passage, he's like, well, I can do this experiment and check it out, and that's, you keep reading until it clicks.
What I find is when I try to watch YouTube videos, it doesn't seem to sink in very well. I don't know if anybody else is the same. I'll remember snippets of it. But I mean, I've watched no end of YouTube videos, and to be honest with you, I can't remember anything I've actually remembered from them. I think when you're reading stuff and you're enthusiastic about reading it, I think you've got to have the enthusiasm there, because if you're just reading it just for the sake of it, you're not going to take it in. You have to want to learn. You know what I mean? You have to want the knowledge, kind of thing. So that's what I always find. Like I say, I watched no end of videos last year, and can I remember anything about them? You know what I mean? I can remember a few things, but not like when you're reading. You know what I mean? It seems to stick there a little bit better. That's my opinion anyway. I don't know if anybody else has got the same opinion of that, but I do find reading it does stick in your head a lot better.
Well, I suppose the reason that Chris has got to here is because of all his reading, that he understands that he can. Series is the same, isn't he?
Yeah, and the good news is they've just released Mooncalc on Android, so go and install it now.
It's very exciting times right now. Everybody's coming together at quite a fast pace, really. Maybe it's not as quick for some people that you can't go, da-da, everything's finished and there you go, but it is picking up speed and people meeting, functions happening, conferences, America, UK, picnic tomorrow. Nathan Oakley's organising that one, Leamington Spa, and then there's all this stuff happening. Series, Chris, you coming on, and all the other people. It's just great. Chat room,
Yeah,
people watching.
It's going to be a busy year because, like I say, I've got the. I went to the Fuca's meeting recently. I went to watch Darren Nesbitt in Manchester. Before that, I've got the picnic tomorrow. I've got the American conference in November, and then I'm supposed to be doing a presentation at the UK one, which hopefully all this information I'm taking now from Mooncalc and Time and Day will be able to build a presentation. The guy at work who does a lot of the presentations at work is going to help me build up a proper presentation. So hopefully that'll be ready for next April.
Cool.
So it's going to be a busy, expensive year.
Yes, Martin in the chat room. It is exciting. Martin Leakey is saying it's exciting. I'm saying, yes, it is.
Yeah, it's pretty expensive and all, to be honest. So
yes.
One thing I will say, and I'll say this till the day I die, I will never ever ask anybody for any money whatsoever. You'll never see a PayPal link on my account, and you'll never see anything like that. Everything I do because I want to do it, and I want to share the knowledge or the findings. I'm not going to charge people to learn, you know what I mean? So
yeah,
I'll try to make sure I get that, make that very clear.
Thank you, Dave.
Okay, right, I've got to go now because I've got to get up early in the morning because Susie's dad's going to
Dave, you know what has to happen? I've got to come back. Just take me a couple of seconds. You're going a bit black, I think.
Yeah, I'm going to have to shoot, guys, but it's been great chatting to you. I know it's been short and sweet, but
we have to have a flat Earth hug, and going to see you tomorrow.
Yes, we'll see you tomorrow. Yeah, we should be there at 12. It's not far from me actually. I just had a look had a look. It's not that far actually, is it? It's only at the other end of Leicestershire, isn't it? Like, so it's not too bad.
Have a group flat Earth hug tomorrow, a real one. Thank you so much for coming on. And today, see you today.
Yeah.
Cheers, Dave. Always a pleasure. Always a pleasure. Cheers.
Cheers, Chris. Cheers, Series. Cheers, Patricia. Who else was there? Robert's there. Who else we got?
Have fun there.
Robert, but I don't know what's happened to Robert. And you might have fallen asleep by now.
Oh, there's Robert.
She shut her hair off.
Robert,
hi, everybody. Oh yeah,
I've
been here the whole time. I did take a little nap from time to time.
Well, Dave, now you've learned some subliminal learning through the sleep process.
Yeah, that's I do it with the Bible. I might as well do it with the Google Hangout.
Right on.
Right, guys.
I enjoyed what I saw. Thank you so much for including me.
But I'll be wearing the Lunar Module T-shirt tomorrow. Flat Earth Asshole T-shirt.
Very nice.
Yeah. Right. I'm going to shoot. Take care.
Everybody's gone for a hug. Yay! Hugs, hugs, hugs.
No
Thank you all.
Please. Right. Thanks a lot. Bye.
Bye-bye.
Bye-bye.
Robert?
Oh, I think Robert hung up here too. Yeah.
Robert thought that was a goodbye to him, did he? The time. We've been going for 2.5 hours now. It's not as long as usual, but a good place to stop, or do you want to talk a bit series? Have you got anything to say, series?
Oh yeah, so far I have a few questions of what kind of objects he actually uses there and how that is built up. So I can actually replicate the model in a sense of how the basic law of life structure works, and see how that actually builds up the rest as well.
Well, are you asking Chris a question, series?
Yeah, well, it's more the technical side of it in the.
Yeah, I think as you get into that program there, and you'll because once you start flipping and flopping it, looking at it from different angles, and I did one there today too, and I noticed that when you double up on the toroids, you'll end up with basically the cross symbol, and it actually lines up with the Vatican City's right dead center in the cross. You believe it or not, it's in the toroid in the center. I was like, that's kind of interesting. Yeah.
Yeah, you might wonder why they chose actually those 3 particular locations for their nation in the nation.
Yeah, and there's other points on the toroids too that are interesting because it'll line up with the South Atlantic anomaly. That one lines up well, and also what's the big mountain in Africa there? Mount Kilimanjaro. It's on one of the nodal points as well, like dead center. And so there's different regions where you can see where the toroids come together at their focal points.
Yeah.
So the one's the South Atlantic anomaly, and the other one's in Australia, and they all line up on the flower of life where they cross. Right, you'll find the focus points right there every time. Yeah. I was like, wow. All right, so now I know why. And the other one is the Bermuda Triangle. There's actually a triangle. You can actually see it in the magnetic field. Yeah.
Well,
Yeah, it's pretty wild. Yep. Maybe I'll share some of that next time. Yeah.
And it's a lot of data to put it into a model, and that you can actually see that. Yeah, I wonder that the particular location of Jerusalem, what you showed, what that particular GPS location is that 0.0
for Palestine?
Oh, Palestine.
Yeah, I'm not sure. You could check it. Just go on Google Earth and do a search for Palestine, and then get the coordinates. I'm not sure if it's 0.0. I can see if I still have it open there. If it'll tell me the coordinates, I'm not sure.
So that particular location, I'm gonna scan for the.
I know who you look like today, Chris. I've got to say, do you remember a band called ZZ Top?
Do I know a band? Oh yeah, yeah. I met Billy and at one time there. It's interesting. They're interesting guys. Yeah.
It's the hat, I think.
Yeah.
Plus, they had long beards, didn't they?
They got the long beards, yeah. Yeah, I used to play a lot of their tunes too back in the day. Yeah. Yeah, I've been fortunate in my travels to have, I guess you could call it, rubbed elbows with a few people along those lines. Yeah. I went to Berkeley there for a while, and I was able to study with Steve Vai online through a live online Skype, this type of thing. We did hangouts, and so Steve was on the other side talking and classmates. It was fun.
Yeah.
I got to go to New York and hang out for 5 days with Paul Gilbert. He was with Mr. Big and Razor X, and he's a world traveling musician as well. Actually, this guitar, this one here, I don't know if you can see that in the picture. This is off topic, because I know it's not flat earth stuff, but it's a Cole Clark guitar. And it was given to me in person by Manelli Jamal. It's his signature guitar series. So he's one of the world champion finger style players. So then he made me this. This is a drawing that he did for me too. It's so he made me that drawing that came with the guitar. Yeah, pretty cool.
Wow.
Yeah, so it's got his John Henry on the back, a little note, thanks, Chris. And yeah, it's kind of cool.
Cool.
Yeah, I've had an interesting run so far. Done lots of stuff. Music can take you a long ways. You meet a lot of people in the music industry. I recommend it. It's good for your mind, right? It helps you think in different spaces and musical tones and notes and the interaction of vibration and sympathetic vibrations. Yeah.
And if people don't realise, you also you were a kind of teacher anyway, weren't you?
Yeah, I taught guitar for about 10 years, I guess, total, off and on. At one point, I had about between 60 and 100 students full time.
Wow.
Back in the 90s. Yeah. Oh, time flies, doesn't it? Yeah.
Wow.
In the 90s, yeah. Then I started actually to explore internet for the first time.
Yeah, I had my first Tandy. Yeah, the Tandy computer. Yeah.
Patricia.
Speaking of which, I'm going to go run and play some guitar and
Yes, I think we've been going for 2 3/4 hours now, and yeah, it's probably time that we. Are you going to play something on the way out then, Chris?
Yeah, time to do some playing in Braxton. Yeah, you guys have a good night.
Could I just say that we're going to not be here tomorrow night. We're going to have Saturday night off, but we'll come back on Sunday. Coming back again. Hello, Judith. Patricia, are you there? Calling Patricia.
Yeah, I'm here.
Hello, my darling. Well, that was an amazing hangout.
Can you hear me?
Hello. We can.
We hear you.
Are you going to play something, Chris?
Well, I could play a little tune I was working on earlier. I was trying to do an interesting. It's a kind of a Celtic. If I can get it going right. It's coming.
Hey.
So I wrote that today. I've been working on that today. So I want to get it finished. Yep.
Series will get his guitar out.
Yeah.
We'll do a jam sometime. Yeah, exactly. That'd be fun. Yeah.
We had a little hangout with Series playing before. I feel I recorded him playing. He didn't know.
Yeah. Blues. We'll play some blues. Yeah.
Yeah, learn a tune to play together. That I learn a part of that, and then that we practice, or how do you call it, jam together, and then.
Yeah, that'd be fun. Yeah, we could do that. They can do a little intro music, little outro music, and yeah, might as well be a little entertaining while we're on here chatting too, I suppose. Yeah.
Look, you want that, don't you?
Yeah. I can play all day long if you like. Yeah.
Yeah, it's playing a chord set, and based on the same chord set, you can actually play the melody on the chords themselves as well. Individually as you can have
music's
chords and the other one playing the melody.
Yep. Yeah, music's part of the soul once you get into the music. Yeah. Yeah. Wouldn't be life without music, as far as I'm concerned. Yeah, that's the kind of the way I talk. Yeah.
Thank you for that, Chris. Anyway, I think we're going to say goodnight to everybody now. Thank you, all the people in the chat room, all the wrenches, everybody that's watching. Thank you to Dave Marsh, Robert Foertsch, and obviously Chris, Series, Patricia, Judith, and see you on Sunday. Say goodbye.
Because
Bye.